data analysis, termasuk di bidang metodologi penelitian dan analisis data. Kiprah akademik beliau juga sangat luar biasa, hingga saat ini telah menghasilkan lebih dari 130 publikasi ilmiah. Itu ya. Dan di berbagai jurnal internasional bereputasi, kemudian juga sudah disitasi hingga ribuan. Kemudian beliau juga aktif menjalin kolaborasi dan riset internasional dengan akademisi dari berbagai negara, serta juga menerima beberapa penghargaan atas kontribusinya di bidang penelitian dan publikasi ilmiah. Pada workshop kali ini kita berkesempatan belajar langsung untuk belajar dari beliau pemanfaatan SmartPLS. SmartPLS ini mulai banyak digunakan terutama ketika in past 2 years, ketika sudah ada SmartPLS 4, di mana sekarang SmartPLS ini termasuk saya juga sudah termasuk tools yang paling sering digunakan karena sudah ada semua lengkap di sini ya. Dari mulai CB, SEM-PLS, SEM, dan bahkan proses Hayes pun sudah bisa dikerjakan di SmartPLS 4 ini. Dan ini luar biasa, dengan satu tools bisa berbagai analisis data. Oke, baik. Without any further ado, kita sambut dengan hangat. Please welcome Associate Professor Dr. Ezlika Binti Muhammad Ghazali.
Terima kasih. Alhamdulillah, syukur kehadirat Allah Subhanahu Wa Taala kerana rezeki ini untuk sampai di UPI, dan sedikit sebanyak cuba share what I know. I don't know everything basically. Saya tak adalah ahli dalam statistics, because the reason I take marketing, the reason that my area is marketing, because I'm very bad with mathematics. That is the reason. Otherwise, I'm already I've already economics, or the reason that is because of my mathematics is not really good when I was at school. So I'm not a statistician. I'm just a marketing lecturer that publish in marketing area, and if you would like to publish in good journal, you need to have the skill of of softwares, and not the skill of a calculation, but the skill of knowing how to see a value and interpret, right? So don't ask me, the calculation, or why is it, that AVE, how to calculate AVE, how to calculate Chromite alpha. I don't know how to calculate, but I know how to interpret the values. All right, can we start? Inshallah, I've already given the link to Dr. Pak Yusuf, Pak Dr. Yusuf. Yeah, given the link. I hope everybody has the link. Okay. The link, and the link is to my Dropbox actually. Okay, let me go through the link that I've already given. Okay. Boleh share screen, the entire screen. Okay, so this going to be these are the links basically. Okay, link tersebut telah di-share oleh Dr. Yusuf. Ya? Belum lagi ya? Okay. So dalam link tu akan ada few document, okay? 2 slides. Right? 2 slides. Workshop 1A will basically the slide for in the morning, pagi, okay? Dan slide second will be in the afternoon, where we, insyaAllah, if we have time, we will do moderation and mediation, insyaAllah. Right? So, saya tidak pasti your level actually. So, that's why I prepare the beginner slide. Okay? The most beginner actually. Because I'm not sure where is the level whether I have to go more, intermediate or advanced. No, basically I don't know advanced. I know until intermediate only. Okay, so these are basically the things that I hope you can download. And there is a course license fee here that I've already gotten from SmartPLS company. Okay, so I hope you can download SmartPLS now. If you haven't, have you downloaded? Okay, what about my students here? Okay, have you downloaded SmartPLS? Right? Do you have the license? Okay, this is the license. This is the license. Okay. Okay. Rahil, can you help Rahil and see everyone whether they are okay? Student license tak boleh. Dia 100 saja. Okay, student license is not good. Dalam SmartPLS dia ada student license kan? Okay, it's not good. That one only can read 100 saja. 100 participant. Okay, it's not good. Okay, let me open satu. Okay, this is SmartPLS, right? SmartPLS website. Okay. Okay, you can download from here, and then you see that if you download, there will be student license, right? You can download from here and install. Okay, once you have downloaded, this is what you see. This is what you will see. Okay. Should I on my camera? Yes. Okay. This is what you will see, yeah? Can you see my screen? Everyone, yeah? This is what you will see, yeah? But it will be empty lah, kosong. Because you tak start apa-apa lagi kan? Macam saya ada dah something here. So yours will be kosong. So how to put the license just now that I've given you, this license, this one, right? So you copy and paste. You copy and paste, okay? You go to SmartPLS here, SmartPLS, and go to switch license, right? And then you copy dekat license key sini. Okay? Macam saya yang ni license key saya yang ada lagi 264 hari. Tapi license key yang diberi di sini adalah license key daripada company SmartPLS yang saya contact supaya dia boleh beri 60. So this license key boleh digunakan oleh 60 orang. Ya, for free until August 4th. Okay? Okay, you can just semua okay. Dah ya? Settle lah. Okay. Okay, I will wait until everybody downloaded and all up and running.
Okay.
Sudah ke?
Okay. Termasuk yang di Zoom, silakan download dan masukkan license key-nya yang Bu Ratu sudah di-share. Oh ya.
Okay, kita tunggu sekejap ya. InsyaAllah.
Oke. Nanti ada chat dari Bu Ratu itu yang Dropbox-nya. Di situ juga sudah ada license.
You don't have to register for Dropbox. Walaupun disuruh jadi register, jangan register. Kalau tak perlu. Kat bawah tu ada kecil, dia kata download or something. You just have to that.
Ya, so, ada tanda panah bawah ya itu. Silakan nanti download.
Yeah. Okay, the link of the material is in the chat box for those in the Zoom, right? In the chat box, this one. Tak nampak kat sini saya tunjuk.
Oh ya.
Huh?
Nggak nampak.
Okay, ada apa-apa masalah ke? Anyone have problem?
Ya, untuk downloadnya nanti silakan di link smartpls.com. Kemudian silakan download dan install. Nanti setelah terinstall, switch license dan masukkan uh, serial license yang ada di attachmentnya ya.
Sedang proses download, Pak.
Can you hear me, everyone? Yeah, can you hear? Yeah. Okay, those that in the, I'm worried on the for those that in the in the online. Dia orang okay.
Okay.
Orang okay ya? Okay. Okay, tengok Ibu Puspo, okay tak Ibu Puspo? Lama Ibu Puspo. Dia tengah connect, belum lagi. Okay. Okay. Tapi tahu lah macam mana ya. So, ada dua slide di sini ya. So on. Okay, I'll teach a little bit. This is for kita mahukan, you know, we would like to publish, isn't it? That is our main, right? We would like to publish, and we'll tell you what are the in thing now to publish. What, you know, good journal are looking at. Okay, all right. So these are the slides that I've shared. Okay, let's go through the slides. This is Tamil. Okay, I want to go to my. See. If I do slideshow. Yeah, I think I tak boleh slideshow. Tak boleh slideshow because I want to change. Unless I have to just need MacBook. Kalau slideshow, it will be, let me see ya. Slideshow apa? Okay, macam tu kan. Masa saya tak boleh pergi mana-mana dah.
Okay. Okay.
Dia lambat sikit. Saya nak tengok orang-orang. Okay. Okay, can we start? Okay. All right. Why PLS SEM? Right. Why PLS SEM? Okay. So previously we used a lot of CBSEM lah, covalence based SEM. Okay. Covalence based SEM is need fitting, right? Need fitting. Okay, they need fit. The data need to be a lot, many. banyak, dia tak boleh data sikit-sikit, 200, sometimes dia tak fit. Okay, right, for CB SEM. So for PLS SEM, basically we are using variance-based structural equation modeling. Okay, what is structural equation modeling? Ada student ke? Bukan. Ada student juga kan dalam online?
Ada.
Okay. Structural equation modeling basically is a regression analysis. All are regression analysis, but we estimate all the regression together in one shot. Okay, if we kalau kita guna SPSS dan kita run regression, okay, kita run regression, linear regression or multiple regression, kita boleh run satu equation, right? Okay. Structural equation modeling is basically we run the equation all together. Okay. So dalam nanti kita tengok different model, okay, different model, and then sebab itu structural equation modeling are very, what we call that, convenient. And PLS SEM ataupun variance based SEM, a lot of people use variance based SEM now is because we tend to have complex models, right? Kita ada banyak dependent variable, kita ada mediating variable, kita ada formative construct, right? Kita ada, for example, higher order dimension and more IV serial mediation. So that's the reason why PLS SEM dengan SmartPLS adalah sangat convenient. Right? So that's the whole point. Okay. And okay, let's move to the next slide. Okay, when we talk about hypothesis testing, okay, this is basically since some of you are already having statistical statistic background, right? This is just basically I'm sure you know what is hypothesis testing. Okay, saya sediakan slide ni saya dengan for those beginners basically. Okay, so hypothesis testing are the hypothesis that we propose in our paper that we would like to test. Okay, so my point here is we have to choose whether to test the hypothesis using one tail test or two tail tests. Okay, one tail test is basically the T value is 1.605, right? For it to be significant. Two tail test is 1.96, right? T test. Okay, so why we have to choose between one tail and two tail? Depending on the hypothesis, the wording of the hypothesis. If the hypothesis is directional hypothesis, we choose one tail. If the hypothesis is non-directional, we use two tail. Okay, apakah itu directional and non-directional? Okay, let me give example. Okay, this is two tail test. Kalau two tail kita ada two tail, so 1.96. Okay, T value dia 1.96. Kalau one tail is 1.645. Okay, this is T value, right? T value. So we need our T value to be 1.645 or above in order for our P value to be 0.05 and below, so that we can reject H naught and accept H alternative. Okay, ini dah macam very complicated already. Just ingat that, okay, we need our P value to be 0.05 and below, and our T value to be 1.645 or below, or above. Okay, dia terbalik ya, terbalik. T test dengan P value dia bergerak terbalik. Kalau P value rendah, T akan tinggi. Kalau T value tinggi, P value akan rendah. So kita nak T value kita tinggi, kita nak P value kita rendah. Itu je ingat. Tak payah fikir pasal benda lain. Okay. Tak payah fikir all this, you know, all this stuff. Okay. Saya pun confused sebenarnya dengan benda ni. Okay. Okay. This is the difference between one tail and two tail, right? So when we use one tail is when we have a hypothesis that is directional. That means kita dah letak positif atau negatif. Dan kita dah ada satu negatif, satu positif kan. Maknanya kita directional lah, ada arah. Right? Okay, macam ni, hypothesis ni satisfaction will positively influence loyalty. That means arah dia positif. Direction dia adalah positif. Jadi kita guna satu tail. Kalau kita punya hypothesis is like this. Satisfaction has relationship with loyalty. Or satisfaction will influence loyalty. Atau satisfaction will have an effect on loyalty without saying positive or negative effect. Then kita guna two tail. Right? Kita guna two tail. So mostly, hypothesis kita perlu ada direction. Sebab dalam paper, especially kalau kita hit Q1 paper, kita nak Q1 scopus at least, right? Kita akan tulis, you know, our literature review, and then our hypothesis development, and we already know that it is, usually we will already know based on the literature that our hypothesis will be negative or positive. So there's no reason why to use two tail, basically. Kalau tak, kita explore. Explore maybe two tail lah. Kita tak explore dah sebenarnya. Kita nak test the hypothesis based on the theory. Kalau kita guna TPB, we know that the theory is positive. Attitude will positively influence behavioral intention in TPB. Perceived usefulness intent. Perceived usefulness guarantee will influence intention to use a computer or to use a new technology. Guarantee. Because why? Literature review says so. So there's no reason to tell. There's no reason hypothesis that is non-directional. Most of our hypotheses are directional. So one tail. Okay? Untuk publish di good journal. Right? You kena dah ada strong development. Have already variable ni kepada variable ni adakah positif atau positif? Okay, positif. Okay, let me test with SmartPLS. Okay? Okay, ada.
Silakan yang di Zoom juga kalau ada pertanyaan,
Ya,
mungkin
ada
bisa
pertanyaan.
sampaikan di
Ya.
chat box. Barangkali ada pertanyaan, silakan. Untuk yang
Kalau okay,
tolong berikan. Kalau sudah oke, silakan yang di Zoom untuk memberikan tanda jempol. Kita ada 88 partisipan. Oke, berarti
partisipan walaupun tak ada soalan, bagi saya emoji.
tolong berikan emoji. Ya, emoji. Emoji.
Yes. Alhamdulillah.
Oke.
Saya okay. Okay, let's continue ya. Right, the next slide. Okay. Okay, these are example of TPB. TPB is theory of planned behavior. Right. Basically jangan guna theory of planned behavior. Ini hanya untuk explanation Jangan guna lagi kalau you want to publish in good journal. Unless your TPB is extension to TPB. Because TPB has already been researched to death. Resurrect again and research to death again. Dia hidup mati. Lepas tu hidup balik. So it's already researched to death. If you would like to publish in good journal, try to use other theory or try to extend theory like TPP or TEM. You can extend or UTAU. You know UTAU?
Yeah.
Right. So you can extend it. Okay, jangan guna UTAU dah. use this. Okay. Yeah, modification also can, yes. Jangan guna simple TPB, that's it. No, you can publish, but in conference or chapters, which is okay also, actually, right? Right, this is TPB. Okay. Extending established theories with context-specific constructs is a common publishable contribution. Okay, where you extend. You need to extend the theory. Okay, like here you can see it extend at COVID-19, right? Okay, COVID-19, right? They extend. Okay, so you can do that and then a new context. Okay, context is not really a contribution also that enough to be published in good journal. Context tu macam Indonesia, okay. Customer Grab ataupun Gojek daripada Indonesia, okay, that is context, right? Ataupun Gen Z, okay, those are context. Or perempuan dan lelaki itu adalah konteks. Okay, so unless if your research is gender studies, then okay, that is your context, that is your study. Okay, these are contexts. In order to be published in good journal, of course the context has to be good, the theory has to be good, but it cannot be that incremental. Incremental tu macam you add without any new, what you call that, new novelty, without any strong originality. You need to have originality. Okay, that is number one, very, very important. Even for me, it's quite difficult, and I'm still trying. Many of my journals has been rejected, a lot. Okay, ada satu journal tu rejected 11 kali. Lepas tu, saya tak nak kira dah. Saya keep on sending. Maybe sampailah dia publish, which is already published, alhamdulillah. Okay, tapi memang banyak kali. Sekarang ni very competitive, ya, because of AI. You know, because of AI, Claude, ChatGPT, a lot of journal receive a lot of application journal submission. So it's very, very competitive now. Okay, right. Next slide. Okay, this is another example, right? So each arrows is actually, this is, you know, what it will look like in SmartPLS. Okay. Partial least square atau PLS. PLS is another name for PLS is partial least square. Okay. Partial least square can be estimated in many other softwares like Adangko, Word PLS, R square. Macam my daughter dia guna R square. Saya guna SmartPLS. Right? R square ke? R square. R eh? R saja kan? Mana ada square kan? Ada square tu lain. Okay, R. Sorry ya. Minta maaf. Apa tu saya rasa macam salah. Dia cakap ya. R. Ya, dia guna R. So there are many other software. SmartPLS is just one software. Okay. This is how R look like. R. Model look like in SmartPLS. Kalau R, you need to code right here. Yeah, you need to coding. Yeah. Okay. So dalam SmartPLS, this is how it look like, and then each one will be represented by hypothesis, right? Betul tak? Okay, each one macam corporation will have a positive relationship with manufacturing performance. Contohnya. Okay, so when we talk about hypothesis, there are many types of hypotheses. One is direct hypothesis. Right? Direct hypothesis. Okay, direct hypothesis will be like this. Cooperation, positive relationship with manufacturing performance. Trust will have a positive relationship towards manufacturing performance. Commitment will have a positive relationship towards manufacturing performance. Contohnya, okay? So manufacturing performance will have a positive relationship to negative relationship to complaints. Okay, ni contoh lah. Itu direct relationship punya hypothesis, ya. So there are other hypotheses like mediational hypothesis. Mediational hypothesis, we treat manufacturing performance basically if the model is like this, that means we can treat manufacturing performance as mediation construct, correct? So if mediation construct, the hypothesis could be, right? If you see in good journal, Q1 journal, you can see how sometimes they will write hypothesis, mediational hypothesis a bit different. Okay, manufacturing, performance, mediate the relationship between cooperation and complaints. Okay, that is non-directional mediational hypothesis. If it is directional, meaning manufacturing performance, positively mediate the relationship between cooperation and complaints. Okay, that's how it sounds. It will sound. Or you can also say that the pathway between cooperation and complaints will go through manufacturing performance. Okay, that's how. You can see many ways people write hypothesis actually. Okay, so bila you dah tulis hypothesis moderation, you tak perlu lagi hypothesis direction. Tadi direction kan? Cooperation will have a positive relationship to manufacturing performance. Right. Okay. Bila you dah ada, bila you nak test, it doesn't mean this is a mediation model. No, you boleh letak apa-apa di tengah-tengah. Tapi tak semestinya dia mediation. Sometimes you test direct. You tak nak test mediation. Okay, adalah salah. Kalau supervisor cakap kat student, ada banyak supervisor even di UM, dia nampak student punya ni macam, this is a mediation. Why don't you test mediation? It doesn't mean like that. You test mediation if you want to test mediation. If past literature say that there is probably mediation. Okay? Kalau past literature, kalau student tu kata no, from my synthesis of my literature review that I would like to test directional hypothesis only, that means I will have four hypotheses. 1, 2, 3, 4. That's okay. But the student have to justify lah. Kenapa dia nak test direct relationship only? Kalau dia nak test moderation relationship, mediation relationship, of course, the student or you as a researcher need to justify why you want to test mediation relationship. Boleh? Boleh. Macam ni kalau ada mediation, right? Ni mediation, right? So ada 3, right? 1, 2, 3 hypothesis. 1 hypothesis, 2 hypothesis, 3 hypothesis, dan you nak yang macam ni juga kan?
Direct.
Direct. This is direct.
And we can compare the
Full mediation, yes. If you want to see how strong is the mediation, whether it's full mediation or partial,
partial.
or complementary or competitive mediation. Okay, that is that one. Yeah, the people lah yang side. Zhao at all, right? That is for hypothesis lah. Mediation, ya. Okay, ada soalan tak daripada online?
Silakan yang bergabung di Zoom untuk kalau ada pertanyaan silakan langsung disampaikan.
Yeah. All right, next slide. Okay, these are some of the books. Okay, I hope you can download these books. Tell me if you can download or cannot download. If you cannot download, then there's a broken link. Okay, sebab banyak sharing forward. So if you cannot download, please tell me. I will give you the link. Okay, these are all the books from my Dropbox. Okay, so these are basically, we can say that the main guidance are here ni. The latest is 2022 PLS Primer. Okay, you need to read all. You need to refer to all. You cannot you cannot think that 2022 is the latest, so I don't have to read to 2014. Okay, sometimes there's information in 2022 that information that in 2014 that 2022 doesn't have. Okay, so you might need to cite 2014 or 2017 also in your paper. Not 2022 talk about something else basically. Okay, so you need to download all these 3 and go through and probably cite in your paper. Okay. So this is Hairbook PLS using R. This is also another Hairbook. This advanced structural equation modeling. I like Garson book because it's very simple, the English. Okay. And this is Wong. Wong is a lecturer in Universiti Malaya previously, also written a partially square book. Okay, you can download all. Okay. Okay, this is the latest one lah, the third edition. Okay. Okay, this is basically the guidelines. Okay. Okay, ada soalan tak? Semua ada soalan, okay? Ada ya? Right. Okay, let's move to the a more complicated one. Okay. So in your paper, in your Q1 paper, these are the things you have to report. One, normality. In this order, normality, common method variance, measurement model. Under measurement model, you have to report whether the measurement model for your reflective construct. If you have formative construct, you have to report for formative construct. And then structural model, you know, if you have mediation and moderation, it's under structural model or direct path. Okay, so these are the order of reporting, not the order of analyzing. Lain. Analyzing, you kena start dengan nombor 3. Tapi masa you report in your paper, you kena report normality, and then common method variance or bias, and then only measurement model. But when analyzing, you have to start with number 3 first. You have to finalize your model first before checking normality and CMV or common method variance and bias. You have to finalize the model. Because when you run measurement model, you have to remove, sometimes you have to remove items in order to improve your average variance expected and so on, right? Okay, we will talk about that later. For those that are not familiar, I think we have to go slowly about measurement model. Okay, remember, 1, 2, 3, and 4. Okay, this is the order of reporting, but we start analysis number 3 first. Okay, analysis must begin with step 3. Okay, so all right, we will start with this later. This is just a warm-up. Okay, exam. All right, this one we will start with this. And all right, first I would like to explain normality first. Okay, just now kan kita dah cakap 1, 2, 3, 4. So this is basically the explanation about 1, 2, 3, 4. Okay, all right, dalam SmartPLS or PLS SEM adalah dikatakan that our data tak payah normal because kita guna bootstrapping. Yes, tak payah normal. It's okay. Okay, ada beberapa isu kat sini. Ya. Walaupun, okay, satu, walaupun tak perlu normal, kita perlu report betapa tidak normalnya data kita. Okay, itu satu isu. Okay. Nombor 2. Isu yang kedua adalah multivariate normality. Normality ada banyak normality. Dia ada item normality. Dia variable, ya, normality variable, ya. Dia ada univariate, that means dia ada macam satu variable tu normality dia. Dia ada multivariate normality. Okay, so when we do SmartPLS, we are actually using multivariate analysis or regression, multiple regression together. Kita guna multiple regression. Kita bukan guna ANOVA ke, t-test ke, tak. Kita guna multiple regression. Kita guna correlation, no. Kita guna multiple regression. Kita guna structural equation modeling where we estimate a lot of multiple regression. Betul ke, Rosen? Nanti salah pula kan. Pandai-pandai je. Okay, when we do multiple regression, we need to check multivariate normality Bukan univariate normality. Okay, yang ni Q1 punya level. Okay. Univariate normality adalah untuk apa ya Rasa? Manubah. Okay. Kalau multivariate analysis, kita kena check multivariate normality yang SPSS tak boleh check. We have to go through this. Okay, we will do that together. Okay, alright. So kita kena, kita perlu report multivariate normality. So you can see the threshold here for multivariate normality. Okay, by client. Client di sini rasanya saya ada bagi. Client here. Okay, you can cite this one, client 2016. So ini adalah threshold dia. Skewness mesti tidak lebih daripada 3, positif atau negatif. Kurtosis mesti tidak lebih daripada 20. Okay, ini multivariate normality. Okay, univariate normality on the other hand is 1 dan 7. Okay, sometimes our data in terms of univariate normality, dia lulus, pass. And then kita happy. Oh, happy ya. Tapi sebenarnya kita kena pass multivariate normality. Okay. So itu nombor 1 ya. Pasal normality ya. Dalam pengalaman saya tak pernah jumpa satu data yang multivariate normal. Tak pernah. Sebab kita social science, we are social science. Bila kita what we call that, collect data through questionnaire, selalunya kita akan ada items and then strongly agree, strongly disagree kan, Likert scale, right? 1, 7 kan, 1, 2, 3, 4, 5, 6, 7 ataupun 1 hingga 5. Okay, kita guna Likert scale. Okay, statistik probably a bit different. Dosen statistik lain a bit. But for marketing and consumer behavior, we use questionnaire. Yeah. We use multi items to measure our construct. Kan? Kita guna multi item kan? Okay. Multi item kita usually kita measure using Likert scale, betul? So usually respondent akan jawab agree ke kanan, skewed ke kanan atau ke kiri. Macam tu. So at the end, kita memang tak dapat normality. Susah. Right? Unless it's a lab. Macam eksperimen science. Science eksperimen, mungkin boleh dapat normality. Untuk social science susah. Especially untuk orang Nusantara. Kita tak berapa, kita apa orang kata tu, bila kita nak normal, kita kena make sure that respondent akan ada yang jawab 5, 6 and then 6 and then 3, 1 ramai. I mean tengah-tengah tu ramai and then yang tepi ni sikit baru kita dapat normal, betul tak? Right? So susah kan kita nak dapat begitu, kita ada ke sini ke sana. Betul kan? Jadi memang susah untuk dapat multivariate normal lah. Sebab tu kita guna SmartPLS. Okay, salah satu sebab kita guna SmartPLS sebab data kita tidak normal dan kita SmartPLS bootstrap supaya dia jadi normal. Dia bootstrap kan, bila bootstrap 10,000 dia akan jadi normal. Dan one very important assumption in multiple regression is that your data is normal. It's an assumption. You have to pass that assumption. Okay? Sebab kita guna multiple regression. Kalau kita guna any statistic procedure, there are assumptions that we have to pass. Okay? So dalam SmartPLS or PLS SEM, kita guna regression. Jadi kita kena pass, kita kena make sure that our data is normal. Kalau tak boleh normal, kita tak boleh guna multiple regression by right. So that's the reason a lot of people move to SmartPLS because SmartPLS boleh bootstrap. In fact, I think M.Stat pun dia dah start boleh bootstrap sekarang. I think. Okay. Lepas SmartPLS bootstrap, dia orang dah include that, bootstrapping mechanism, as well as, I think SPSS pun dah start boleh, if I'm not mistaken, the latest one. I think, okay, I'm not sure. I think, maybe you can explore, okay? All right, so multivariate normal. Okay, next. All right, okay, this is number one. Where is it? Okay, number one, this one is normality. Okay, number two is common method, bias and variance. Okay, very, very important to be published in good journal. Sekarang ni, good journal akan tengok benda ni. Kalau tak ada ni, dia akan reject. Just reject. Okay, especially kalau you use survey, questionnaire. Right? So, what does it mean by common method bias or common method variance? Common method bias atau variance akan terjadi. There are many bias. There are many bias in data. Salah satu adalah ini. Common method. Common method. Okay, perkataan common method tu bermakna kita guna satu method. Satu method. Common. Untuk collect IV dan DV. Kita guna questionnaire. IV dan DV semua di dalam questionnaire tu. Betul? Demographic, IV, DV. Mediation, moderation, semua dalam satu questionnaire. So, bila responden, kita bagi responden, bila responden jawab, dia mesti ada, apa orang kata tu? Apa ya? Bila you jawab 5 di atas, you akan jawab 5 di bawah, you macam, that is the bias, human bias. When jawab 5, 6, 5, and then bawah pun IV semua 5, DV pun 5, moderation pun 6, so dia bias. Bias where you tend to see yes. Kalau yes atas, bawah yes. Right? Itu namanya common method bias. Okay, kalau kita tak nak common method bias, macam you guys perguruan kan, pendidikan kan? Okay, kalau pendidikan di Malaysia kebanyakannya diorang akan buat research begini, dia pergi sekolah, student di sini, student 30 student, so IV-nya daripada method lain, DV-nya daripada method lain. Contohnya IV-nya mungkin variable seperti, terima kasih, variable seperti anxiety in exam, contohnya lah. Ataupun time in doing ulang kaji sebelum exam. Okay, 2 variable. 2 variable dan juga maybe personality of the student. Okay, so these are 3 variable IV, independent variable. 3 variables. Okay, letak dalam questionnaire and then the student will answer. Tetapi DV, dia mungkin akan suruh cikgu ataupun guru yang isi. The performance of the student. So you can see here it's not common method. IV, student yang buat. DV, pesyarat, guru yang isikan. So dia tak ada isu common method. Tapi untuk consumer behavior memang ada isu common method. So untuk publish di good journal, if you use murid-murid, pelajar-pelajar sebagai responden, you boleh guna method ni. IV different, DV different method in collecting the data. Macam company mungkin boleh, okay? Kita collect
Employee performance, ya.
Yeah, sama. Can do that. Employee performance. Kalau consumer behavior, kebanyakannya satisfaction semua di dalam questionnaire kan. Kalau tidak mahu common method di dalam consumer behavior research, you can get data from company. Berapa banyak dia beli, right? Berapa banyak profit daripada customer ini, tapi susah nak dapat. Mana ada company nak bagi? Tak ada company nak bagi, kecuali kalau the company is your father's company. Dia akan bagilah. Sebab tu dia ada isu common method bias, ya. Okay, common method bias, cara untuk what we call that, handle common method bias. Okay, kita guna questionnaire juga seperti biasa, tapi you have to add marker variable. Another variable that has nothing to do with the model at all. Marker variable means another model, another variable that has nothing to do with any construct in your model. You have to add that inside. Okay, ini daripada Lindell and Whitney. Okay, maybe you can read this paper and read, this suggestion daripada Lindell and Whitney. Dia ada banyak cara. Satu, full collinearity technique if you don't have marker variable in the questionnaire. If you forget or you don't know that you have to collect marker variable, you have already collected the data, then you can do full collinearity technique. Okay, and see the VIF, variance inflation factor. Okay, VIF, dia ada banyak lah. These are the threshold for VIF. Okay, so kita nak VIF. This is the more stricter. Lebih strict lah, lebih rigid daripada COP 2005 atau COP and LIN 2012. This more stringent. So VIF lagi sikit, lagi kecil, lagi bagus. Maknanya dia tiada common method bias. No, bukan tiada common method bias. Common method bias is there. But you can write in your paper that common method variance or common method bias is not a concern in the data. You cannot say that common method bias is not there. You use common method. So there will be bias. You just check whether it is a concern or not a concern. That's it. And report in your paper that, okay, based on the full collinearity technique that we have done, the VIF is less than 3.3 for all the variables. That means common method bias or common method variance is not a concern. Or if you use approach 1, which is marker variable technique, this approach 1, and you have already collected marker variable data in your questionnaire, you can also say the same thing. Okay, you can also report that. I will show you how to report it, right? And you can also say that common method bias is a concern or not a concern. Okay, right? Okay. Okay, all right. Okay, next slide. Ada soalan tidak? Yeah, okay. All right. Okay, I've already explained here why we need it and how the technique addresses CMV. CMV is common method variance. The problem is common method variance or bias could be an issue in the study because the same people give answers for both the IB as well as dependent variable, DV, at the same time using the same method. That means we have common method bias, okay? So this is a problem. Okay, the solution is to handle CMV or CMV. Okay, CMV is variance, CMV is bias. Follow the advice of Podzakov et al. Podzakov et al. 2003 basically, by using a marker variable. This marker variable, single common method factor, or we call it marker variable. And you can use the PLS marker variable method to create this factor, this by Ronco. Okay, I will show you this as well. Okay, so 3-step procedure. What we do is, okay, we have the variable, marker variable model. Okay, we have to compare the R square. Okay, remember, we have to compare the R square. Okay, let me explain a little bit about this here. Okay, for example, this one, this is our model, for example. All right, this is our model. And then we will have one marker variable here. Find the pen. Okay. Okay. So imagine this is your model. Okay. When we use marker variable, that means we have to collect another variable called marker variable. So here will be the variable. Okay. The variable also is multi-item. Okay. Multi-item. So what you do is, all right, you can see this is a dependent variable, correct? Sorry, this is a dependent variable. This is independent variable, correct? Okay. This is a, we also can call this predictor variable. And this is outcome variable. Okay, so you can see arrow here. Arrow. Okay, so this one no arrow, right? Towards it. Only here got arrow, right? Okay, so if something got arrow like this, you can see R square, right? Afterwards. Right or not? Betul tak? Okay, yang ni tak ada R square kan? Sebab tak ada arrow pointing towards it. This one will have R square. This is called also, we call it endogenous variable. Endogenous variable. This is exogenous variable. So when we talk about marker variable, when we run SmartPLS, right? Like this, we run like this first, and then we check R square. We check R square. Okay, contohnya lah, R square ni 0.4 lah. Contoh. Okay, okay, we write down 0.4. Okay, and then we run again, but this time with marker variable pointing to this. Pointing to the endogenous variable. And check R square again. Maybe R square is, bila dah point macam ni, R square jadi 0.42. Maybe, yeah, because more arrow pointing to it, right? This one 1, 2, 3, 4. And then we add another 5, another one 5. So we want to see the changes in R square before and after, before adding marker variable and after adding marker variable. And the changes cannot be more than 10%. If the change is more than 10%, that means common method variance is an issue. You have to collect new data. So that's why marker variable be a variable that has nothing to do with any variable here. Not related. Try to, of course, there's a correlation a little bit, right? All variable will be correlation a little bit, but not like theoretically. The relationship. So usually I will attitude toward color blue. You know, usually I will show you the attitude toward color blue by Miller and Simmering. Okay, the name is Miller. M-I-L-L-E-R. Okay. Okay, usually I will use attitude toward color blue. Attitude toward color blue. So ada 3 items. Satu, I like blue color. I like blue car. I will, if I want to change car, I will choose blue car. Basically, that's all. We are sure that surely this one doesn't have any relationship with any variable, correct? Because it's blue. Unless if your research is about color, ambience, color of the paint, then you cannot use attitude toward color blue. If your variable are usage, attitude, customer satisfaction, loyalty, engagement, you can use attitude toward color blue. Okay? Right. Ada soalan tak?
Okay. Ada pertanyaan?
Ada pertanyaan?
Bapak Ibu yang di...
Tolonglah tanya soalan.
Tadi ada pertanyaan, Bu Ratu tadi nanya. Bagaimana memilih, how to choose the marker variable? Tapi thanks already answered by you. We use not relate to any construct, not relate to any variable. Okay.
Try. Of course, they will have a relationship and to be correlation. Yeah. If you put anything together, there will be correlation. Oh,
theoretically,
nothing.
Jadi
So,
secara teori. Oke, ada beberapa yang suka memasukkan negative question.
Okay.
Apa itu juga marker atau enggak juga?
Itu bukan marker. Itu hanya bumi track. Bumi track itu apa ya?
Coba.
Apa dia?
Ya.
Ya, dia macam kita nak track people. Dia baca betul ke tidak?
Ya.
Faham tak?
Ya.
Tapi the thing is, 3 items. Kalau satu adalah negative wording, you kena delete. You kena remove. Bila you run factor analysis, you always have to be removed. Somehow, sebab especially kalau di Nusantara kan, kita walaupun kita tak suka something, kita tak cakap 1 atau 2. Yang lain 5. Tiba-tiba yang ini 3. Kan? Betul tak? Faham tak? Okay. Loading. I'm talking about loading. Okay. Macam ni loading. Okay. Item 1 positif. Item 2 positif. Item 3 negatif. Okay. Item 1 kita setuju. So kita letak 5 pun di sini. Kan? Tapi yang ni kita tak setuju sebab dia dah terbalik. Tapi kita tak letak satu. Kalau item dia, jika saya satu ini 5, 5, jadi patut letak satu lah. Tapi kita akan letak 3 atau 2. Sebab kita memang secara culture, kita cannot say no.
Kan saya no.
So, kalau kita nak tengok factor analysis, loading adalah correlation between each other. Kalau correlation dia rendah, correlation sudah jadi rendah, kita kena remove. Because the loading becomes lower.
Ya, orang timur kita sungkan gitu ya untuk ngisi satu tuh sungkan, padahal pertanyaan negatif gitu, itu sungkan dan
So, saya usually tak.
malah bisa membuat jadi lebih bias ya ketika ada yang ngisi 3.
Kalau nak guna macam ni, you tambah lagi item. Kalau delete, kita masih ada 4.
Oke.
Kalau mahu jugalah buat. Kalau perlu. Tapi saya akan semua positifkan.
Positif.
Sampai negatif saya positifkan. Sebab penat saya collect data kan. Kita collect data susah tau. Kenapa kita nak delete anything? Kan kita tahu dah. Saya tahu dah dia akan low punya loading. Dan I have to delete it. So saya akan positifkan. Tapi boleh kalau nak. Tapi make sure jangan guna 3 item. No. Guna 5. So that satu delete ada 4. Mungkin satu lagi perlu delete. Mungkin ada 3. 2 tak bagus. No. Content validity is bad. Okay, when we talk about validity, there are content validity, right? There are convergent validity. There are phase validity. Content validity. Okay, bila kita macam ini ya.
Ya,
yang ni,
item indikator, item pertanyaan ya.
Ya. Yang ini ada 5 items betul? Okay, item ini item in statement lah, statement. Kita tanya, contohnya attitude is I like, yang ni usage apa ni? Okay, item lah, item 1, item 2, item 3, item 4, item 5 di dalam questionnaire. Okay, untuk measure attitude. Betul? Kita tak measure attitude directly. No, kita tak measure attitude. Sebenarnya kita measure 1, 2, 3, 4, 5. Dan kita assume that 1, 2, 3, 4, 5 ini measure attitude. How to assume? Kita tengok literature. So, 1, 2, 3, 4, 5 ni, kita assume that ada content validity dengan attitude. Dia ada content. Ini adalah content attitude. Kalau buang ini, maknanya content dia dah kurang. Walaupun mungkin convergent validity dia tinggi. Mungkin combat alpha dia 0.9. Tapi content dia, the meaning of the construct has already been shaken now because previously it's supposed to be 5, right? It encompasses the meaning of the construct attitude. But you have delete 2 or 3, you left only 2, even worse. Minimum is 3. PLS SEM pun ada satu nada.
Bisa. Ya, ya. Each indicator have more than one question. Oh. We have to singing.
Lagu kebangsaan. Baik, macam mana saya nak? Should I?
Ya. Hmm. Oke. Hmm. Hmm. Oke. Ya. Oke. Oke. Kita akan break dulu 15 menit. Oke, untuk 10 menit ya. Kita akan break dulu. Sambil menunggu break, silakan untuk peserta yang di Zoom untuk mempersiapkan Smart PLS-nya. Kalau yang belum download, installkan nama ya yang tadi sudah di-share di chat box ya. Baik, Bapak Ibu silakan. Yang di ruangan juga boleh break dulu.
Contoh adalah, you have 10 statement indicators. So dalam 10 statement ni dia bagi, is it, to different dimension? Is it?
Ya.
Yeah.
Ya.
So the different dimension will be higher order dimension of the first order dimension. Yeah. Wow.
Oke, Bapak Ibu, insya Allah kita akan mulai kembali. Eh, Dipersiapkan lagi untuk fokus kembali untuk mengikuti workshop ini. Silakan Bu.
Okey, suara dah ada ya? Okey, baik. InsyaAllah. Okay, let's continue ya. Okay. Alright. Yeah.
Ini ada pertanyaan mereka saya bahasa Indonesia aja lepas. Habis itu ada bootstrapping gitu kan? Yes. Apakah itu wajib?
Wajib.
Wajib. Lalu bagaimana kaitannya dengan pengolahan data berikutnya dan bootstrapping ini kan gitu ya? Kenapa ada sampai 500 atau 50 kali gitu ya seperti itu sehingga manfaatnya seperti apa? Pengaruhnya seperti apa? Itu saja yang bootstrapping. Ini wajib setiap SEM-PLS ada bootstrapping yang manfaatnya seperti apa tujuannya. Sangat mohon. Makasih.
Okay. Sekarang bootstrapping basically dulu 5,000. Sekarang 10,000 kita kena bootstrap. Ya. There's a research I think by Hair 2022 punya buku, right? Hair actually show that what happened when you bootstrap 500, what happened when you bootstrap 1,000, what happened when you bootstrap 5,000 and 10,000. So according to Hair, dulu 5,000 like last year probably 5,000 or last 2 years. But now semua 10,000. Why? Because we want it to be normal. Like we have to make sure that the assumption untuk kita guna multiple regression tercapai normality. Itu kegunaan bootstrapping. Kita wajib bootstrapping. Yes. 10,000. 10,000 untuk publish lah, untuk publish in good journal lah. Kalau nak ajar student, sometimes kalau 10,000 tu lama kan, sometimes kita kena tunggu lama. If you just would like to teach your student or would like to check whether significant or not significant, we can just do 500 or 1,000. Tapi untuk akhir, final one, where you would like to publish, you need to do 10,000.
Oke, izin menambahkan ya Bu ya. Jadi kalau dari sisi statistik itu ada namanya central limit theory,
Yes.
dalil limit pusat ya. Jadi kalau semakin banyak sampel itu akan semakin membentuk kurva normal. Jadi yang dilakukan di bootstrapping itu kita melakukan resampling. Jadi karakteristik sampel yang terkumpul yang di bawah 100 itu kita duplikasi. Tadi misalkan jadi 10,000 Bu. Dengan karakteristik yang sama, kita bukannya mengakali data tapi sampling dengan karakteristik yang sama sampai ke 10,000. Dan nanti ketika 10,000 itu kalau kita plot itu semakin mendekati kurva normal gitu. Jadi tujuannya bootstrapping seperti itu. Itu ya.
So
Multivarian. Ya. Ya.
normal sebab tu kita kena buat bootstrapping.
Ya.
Memang kena normal, harus.
Ya. Minimum. Oh ya. Cukup. Ya. Oke. Bootstrapping. Oke.
Okay. Contohnya lah, selalunya kita akan dapat responden 300 lah untuk social science kan. It depends on how complex our model lah kan. Kalau model kita tak kompleks macam ni, TPP ni tak kompleks, maybe 150 dah okey. Okay. Tapi kalau data kita sejuta, okay, sejuta, in order to estimate t-value in SmartPLS, you still need to bootstrap. Cara dia memang macam tu. Kalau you nak estimate t-value, dia bootstrap. So you can bootstrap 100, dia masih produce t-value. You can bootstrap 500, masih produce t-value. Okay, but now the latest the latest meteorological suggestion is 10,000. Right? So tadi Prof tanya about the difference between the whether sampel 10 100. Okay. If your student said, okay, tak apa, kita collect 150 saja, kan kita guna, tak boleh lah macam tu. Kalau your population is big, because when we talk about sample, ada dua, satu representativeness, satu generalizability. Right? It has to be representative of that population. So if your population is big, like internet user, for example, you have to make sure that you get all the range of internet user or a consumer of a product. You have to get the range. So usually I will ask my student to collect 350, 400 and then bootstrap. Especially if you have higher order dimension and all. Lagi tak 300-400. Sebab bila dia bootstrap, dia ambil daripada data kita. Kalau data kita salah, dia akan bootstrap the same data. Kalau data kita is not good data, they don't actually create new data. They actually bootstrap from our data. So our data need to be good to start with. So if you get only 100 because of your sample population is small to start with, then it's okay. You can justify that the population is employee SME is small to start with, then it's okay, right? If your sample is individual people, there's no reason for not effectiveness, kan?
Oke. PLS.
Contoh susah nak cari sampel. Yeah.
Ya.
Nak cari sampel, right? It depends on the this thing lah, the population. Sebab tu my research are usually individual people, consumer. Tapi kalau your research is about SMEs, susah lah, tapi boleh lah. Sebab tu kita ada, dulu susah lagi sebab kita guna SPSS dan Mohd. Bila ada SmartPLS, bila kita guna PLS SEM atau variance based SEM, dia memungkinkan data yang sikit untuk di bootstrap dan di estimate parameternya, untuk multiple regression. Memungkinkan. Ya. Dulu susah. Adakah saya menjawab soalan? Mediation. So bell test. Okay. Betul. Very difficult to get good result for mediation. Itulah. Sekarang ni dah okay with SmartPLS. So now people already move to SmartPLS. Paper macam Zhao et al. Nanti saya bagi paper kepada Prof. Room to Sanatam. Okay, those are papers that are against Barron and Kenny method even. With you. Yes. Ada untuk student yang di Universiti lepas tu bila mediation, higher order construct, there are many other new method.
Okay. Mungkin ada sedikit soalan mungkin Prof. Terkadang masih perbedaan persepsi.
Iya, betul.
Perbedaan persepsi mungkin antar sesama dosen mungkin ya. When we use CBSEM, when we use PBO, when we use just simple regression. Itu mungkin yang kadang masih kan kita semacam behavior perception, which is student still regression. The variable is dianggap sebagai laten, tapi sebagai nah ini mungkin ya kalau yang pada data, tapi kalau misalkan yang berkaitan dengan behavior, terkadang masih ada yang menggunakan regresi gitu. Itu mungkin Prof mungkin bisa jelaskan.
This is observable. Ini bukan observable. This is manifest variable lah. Okay, this is not. This is unobserved. Unobserved, observe. Unobserved, observe. Observe, unobserved. Kita assume we are measuring this. Kita observe this. We measure this. Assuming after measuring this, we are actually measuring this. Okay. Contohnya ruler untuk measure apa? Okay. Ruler thermometer. Okay, thermometer untuk measure heat, right? Warm, heat. So, yang itu kita measure objectively, right? Ruler, kita guna ruler untuk measure objectively. Kita guna, that weighing scale untuk measure weight objectively. Right? Kita boleh nampak ya, scale and all. But this one is the ruler. We don't have the thermometer for social science. Perception. Yeah, opinion, attitude. We don't have that ruler. Okay, so this is our ruler basically. So we have to make sure that our ruler is correct. We are assuming that after measuring at one, using measuring. Sebab tu yang kita kena go through the measurement model assessment. We want to see whether measurement is to measure validity, reliability. Okay. Okay. This later, later, it's not seen. Yes, it's not. Yeah, it's measured by this, not directly measured by. We are not actually measuring this. We are measuring this, and we are assuming that when we measure this, we are measuring the latent variable, which is attitude. Similar with others, lah. Okay, so the thing we measure this. Right, these are latent. That's what they call latent. There are many names of latent lah. Satu latent variable. Panggil apa ya? Ada names,
Ya. Ya.
yes. Variable. Okay, yang ni dipanggil observable, manifest variable, dipanggil ada few names tapi basic it can be called also items and statement or indicators. Okay, ni dipanggil item, statement atau indicators, right? Tapi kita boleh panggil juga sebagai variable, tapi observed variable. So sometimes student, bukan student lah, kita pun researcher kita confused. Kita akan cakap ini variable, ini yang variable, ini bukan variabelnya. Ya, ini variable. Ini pun variable. Yang ni yeah. Kan? Tapi ini adalah variable. Satu variable, dua variable, ini semua variable. Kan? Okay. Ada apa-apa soalan lagi? Yes. Ya, boleh. Boleh. Ada banyak yang boleh instruksi. Okay. Betul.
Di situ variabel, ada indikator, namun di situ data dengan termasuk statements, opinions, terus kemudian ya apa tadi akan datanya kan berupa data yang bersifat order persepsi gitu. Data yang dipergunakan misalkan seperti itu tadi, data SDGs, namun di situ kan ada indikator-indikatornya, namun indikator tersebut nilai dari data itu berupa indeks rasio, bisa nggak menggunakan maksudnya diolah menggunakan dengan model seperti ini menggunakan SmartPLS gitu.
This is the model, right? Okay, kita yang ni bila arrow dia keluar macam ni, kita panggil reflective construct. Reflective construct adalah item kalau index selalunya kita akan guna formative construct. That means this arrow going in. Okay, ni. This arrow. Go now. index, index. So X ini ratio, cakap ratio, it's actually correlation. Correlation between this and this. The higher the correlation, that means the loading is higher. Index ini yang form. Sebab index ini adalah ratio dia tinggi. Sebab itu variable ni tinggi. SDG 4 contohnya. Okay, SDG 4, company tersebut tinggi dalam level SDG 4. Contohnya. So maknanya dia telah aktiviti-aktiviti yang dia buat, indeks saya macam doktor cakap tadi, this as a reflective. Reflective adalah macam ini. Formative are different. Formative needs more data. Because when these are correlation basically, regression. Regression, yes. These are regression.
Oh ya, bisa. Ya, informatif.
Bisa. Biasa tunjuk itu. Saya macam ni. Jadi clear order. Okay, clear. Close. Still there's a pen. I don't want the pen. Okay. All right. Okay. So let me see. Thank you so much. Okay. Contohnya, ini adalah indeks ya. Nampak? Ini adalah indeks. Dia products. People I know are concerned of the environment. So for example, if that person akan jawab tinggi, right? And then semua correlate between each other very strongly. It's a reflective construct. That means arrow dia keluar. Right? Kalau formative construct seperti ini, like macam ini, donated money, boycott a product. If you are an don't boycott a product, no. Contohnya lah. Okay, tak. No. People will say yes, or no, until the end. Ini penting bagi dia social pressure untuk upon being green. Social pressure adalah important. Dia akan jawab disagree kalau 1 hingga 7. Kami binary no. Yes, correct. Yes. So that's is you know that you want to use SEM-PLS. You have to design your questionnaire. Yes. Try lah. We get data and then people ask us to analyze lah. Dan yes and no susah macam ni kan. Kalau yes and no kan. Alah. Yang ini ni semua formative. Yang ni reflektif semua. Yang ni activist, avoider, green consumer. Dia campur-campur dah sekarang. Dan saya bahagi between ethnicity. Malay and Chinese and Indian, I think. Kalau nak sudah lama paper ni. Sudah lama saya dah lupa. Tapi saya ingatlah, this is one of the people that, okay. Yang ni tengok, convergibility of formative construct. Lain. Sebab dia adalah regression. Regression kita kena tengok t-value. T-value. Regression, basically kita tengok whether the items is significant or not. Related to the latent variable. Kita tak tengok loading. Loading is correlation. Formative adalah regression. Kita tengok beta. Ni adalah beta lah. Ni kita panggil auto weight. Beta. Kita tengok beta dia adalah significant or not. Ini semua adalah formative. Formative. And then ada yang loading. Okay, formative. Okay, reflective construct different. This is reflective construct where we look at loading and average variance extracted and composite reliability.
PLS.
Yang ni PLS. Macam ni.
Oh, ya, mungkin. Ya,
Yes.
ya, satu kali. Ya. Ya. Izin menambahkan ya, Prof. Mungkin gini, ada perbedaan satu lagi antara CB-SEM dan PLS-SEM, CB-SEM dan varian base-SEM. Untuk yang CB-SEM, yang biasa kita olah pakai AMOS, itu hanya bisa reflektif.
Yeah.
Itu nggak bisa kita balik arahnya. Jadi kalau kita bikin panahnya pasti selalu begitu. Nah, di PLS itu kita memungkinkan adanya formatif. Ataupun combine antara ada yang formatif dan reflektif gitu. Jadi lebih fleksibel. Betul. Ya, nanti tinggal dibalik, diklik kanan jadi informatif, akan formatif. Nah, ini juga mungkin yang merujuk dimensi dan reflektif. Misalkan dimensinya kan tuh sederhana, kalau apa ya, pembelajaran yang baik itu misalkan ya. Juga kalau yang formatif misalkan jumlah jam pelajaran, kemudian jumlah pertemuan, jumlah rombel mengakibatkan pembelajaran yang baik, itu formatif gitu. Nah, maksudnya itu kadang ada yang ngambil dimensi formatif dipakai di reflektif. Nah, itu hati gitu. Kadang dalam di letter view-nya harus pastikan apakah formatif atau reflektif karena akan sangat berbeda apalagi ketika diolah gitu. Itu sih mungkin perbedaannya itu. Soal bisa kalau misalkan di teori yang dibajak gitu ya. Tapi bisa juga yang sifatnya apa tadi ya. Kita belum tahu nih tadi pembangunan efektif itu faktornya gitu ya. Kita apa sih yang membentuk dan yang bagus itu? Kita punya tadi bisa juga berupa indeks atau seperti apa? Itu mungkin nambahin. Ya.
Lagi satu paper saya, right, about formative lah. Ada sikit about formative. This paper, which is Q1. Q1 A plus, A star. So about restaurant choice and religious obligation in terms of serial mediation model, right? So the questionnaire ni, if you see the indicators, it's all but okay, so institutional pressure has lower order dimension yang di collect datanya aktif. Dia jadi aktif. That means they call it tier 2, reflective formative construct. Tier 2. Reflective di bawah order. Tapi bila dah pergi ke higher order, dia jadi formative. Ini buat dalam SmartPLS. M tak boleh. M tak boleh buat. Nak clear contoh ni ya. Ni institution perceive motif praktik. Okay. When ini adalah institutional pressure. Okay. Institutional pressure. And then bila dipanggil formative, that means these three construct bukannya items construct dia as a formative kepada IP. So tapi bila dia di measure adalah reflective. Faham tak? Measurement dia adalah ini dipanggil higher order. So dia bila dia which is beta, dia panggil weight lah, but actually is beta. You have to see whether the beta is significant or not. As you can see, it's not significant. Okay. Okay, THC also second order, bukannya yeah. Yeah. Buat second order kan. Daripada literature. Semua daripada so memang dia ada problem lah sometimes, you know, sometimes yeah. Order tiba jadi first order. Sebab second order doesn't work. And saya pun ada. Yang ini saya tak nak. Tapi jadi no first order. Tapi because these three, they don't discriminate. HTMT dia tinggi. Jadi dia tak discriminate. They are not actually totally different variable. Jadi saya terus yang tak ada. Yeah. Yang ini ada masalah. Maksudnya sahaja. Kan? Tapi kena dengan yes. Salah. Mm-hmm. Kita untuk as my meet ya. Soalan dia batuk. Batuk. Biar saya draw sikit lah. Draw apa pasal word? Macam mana nak draw pasal sini. New slide. Okay. Alright. Okay. And reflect. Okay. So ini dipanggil lambda. Bukan lambda. R. Loading. Okay, dalam SPSS kita guna factor analysis. Dan kita pun dapat loading. So, ya, kita dapat loading. Kita tengok loading tinggi. 0.5 maybe delete ataupun ada cross loading kita ataupun something like that, right? That's how we di dalam SmartPLS dalam SPSS that are of similar value walaupun satu 0.9, bawah tu 0.6, bawah tu 0.7, 0.8, kita agree that okay, these 4 items actually measure this latent construct. At the end kita campur semua, bagi 4. Betul tak?
Ya.
So kita assume that they have the same loading sebenarnya. Betul tak? Kita assume kan? Okay, tengok kita run factors. Okay, mula kita run factor analysis. And we see that loading above 0.6 depending on, you know, your school of thought. From 0.6 kita take 0. The items. So contohnya kita 4 item kita okay. Imagine in SPSS, what we do untuk jadikan dia construct, kita tak kisah yang ini sebenarnya 0.9, yang ini sebenarnya 0.6, yang ini sebenarnya 0.6 juga, ini sebenarnya 0.8. Kita assume yang ini pun sama dengan ini level. Yang ini 0.9 contohnya, loading, maknanya dia lagi power lah loading dia, lagi power. Yang ini kurang power. Tapi dalam SPSS kita assume semua power dia sama. Tapi SPSS, SmartPLS, dia tak assume. Dia tak assume kan? Kita run. Kita tak ada step 1. Step 1, kita settle management model. That is SPSS. Kita averagekan semua. Kita jadi latent variable score, whatever lah, gitu kan? Baru ke so loading yang 0.6 remains 0.6. Kekuatan loading yang 0.9 means 0. Kita tak average. We don't average. Confused? Okay, Ron. Betul.
Satu item. Ada several question.
Oh, iya. Iya. This was like one, right? Right. So ada yang ada jawab 5. Voting lah. Kita tengok satu kolom ATT1, ATT3, ATT4. So, saya voting lah. Yes, min. Betul kan? Min. Yes, correct. Soalannya? Soalan.
Jadi second orang.
Okay. Like I said just now, right? Bila kita ada higher order construct or higher order dimension, it is actually from the literature. That is nombor 1. From the literature. Literature already said that this variable ada dimension dia. Macam contohnya switching cost. Switching cost kan ada banyak dimension. Contractual cost, monetary cost, time cost, effort cost. Tapi dia adalah time cost dengan effort cost adalah different thing. Tapi dia adalah dimension yang ke bawah untuk dimension yang ke atas, yang tinggi, kan? Betul. Dia dimension yang bawah. They are different. So you cannot combine them. Combine the items. Cannot do that. You have to make sure that they remain in their dimension. Because each dimension is a construct. Dia ada dia punya own operational definition. Right? Kalau you dah literature kata, you know, this construct has operational definition A. This construct operational definition B, and seterusnya. They remaining 2 constructs. Although they probably overlapping, that's the reason you need to do the second order, sebab they overlap. You tak boleh campur macam ni walaupun Cronbach alpha tinggi. Sebab the more items, guarantee your Cronbach alpha akan tinggi. Kalau you ada 10 item, 15 item, you tengok Cronbach alpha guarantee tinggi dia. Kena dimensi. Kalau literature cakap begitulah.
Gimana kita?
Literature tu kena ada. You tak boleh campurkan 15 items. Tak boleh. Dia masih kena higher order dimension. Because that is how it is operational. That is how it is operationalized. Most are structural equation modeling. MOS pun, SEM, SEM, MOS pun. Tapi MOS ada covariance based structural equation modeling. PLS adalah variance based structural equation modeling. Dua-dua adalah structural equation modeling. Mungkin cara algorithm behind it is different. I don't know, maybe Pak Yusuf, statistician would know. Okay, about the data, sama ada perlu collect data ataupun boleh data yang sedikit untuk guna PLS-SEM. Okay, untuk MOS memang kena data banyak. Untuk covariance based SEM macam MOS Lizrel, ya kena data yang banyak sebab dia ada lagi covariance lah apalah macam tu kan. Dia ada lagi ekor-ekor dia. Right? Dia ada banyak yang kena estimate. And then dia ada fit. Dia kena tengok dia punya GFI, goodness fit index, NFI, benda-benda tu semua. Walaupun dalam SmartPLS pun boleh buat sekarang ni, tapi mostly in covariance based. Okay? Of course dia kena data yang banyak. Kalau tak, dia tak boleh fit. Dia doesn't work. Dia just tak boleh fit. Tapi yang saya tahu, yang dalam MOS pun sudah ada bootstrapping sekarang ni. Mungkin boleh fit. Okay, sekarang ni dah new evolution. Okay, for PLS SEM, yes, dulu memang orang kata boleh small number of sample. But like I've said just now, small number of sample, is it enough sample? Enough story? Enough, what we call that? Representative enough tak dengan sampel yang kita nak represent? Contohnya, our sample is internet user. Kalau you collect hanya 100, dia boleh cover semua internet user tak? Tidak. Walaupun SmartPLS boleh run. SmartPLS is just a tool. Hanyalah satu software. Dia akan run apa benda semua, dia akan produce something, values. Kan? Walaupun 50 pun dia boleh run. 100 pun dia boleh run. Tapi tak semestinya data kita atau sampel kita tu representative of the population. Itu satulah. Tapi kalau data kita memang sikit dan susah nak dapat, contohnya ada research about LGBTQ ataupun research about cancer patient ataupun memang susah nak dapat, ataupun autistic children, refugee people, then okay. Jangan guna MOS, tak boleh run, boleh guna SmartPLS. But it doesn't mean you should get small sample. To the best of ability, get more sample. Untuk sama ada boleh run atau tidak, yes, dia boleh run. SmartPLS boleh run. Tapi untuk publish in good journal, susah sikit lah. Unless if your population is difficult to get. You can say that my population is refugee and orang asli ataupun cancer patient. That's why you can get published because the sample is difficult. If you say that, oh, it's just an internet user yang guna ataupun customer Gojek, tak boleh lah. Customer Gojek, UMP boleh jadi customer Gojek. The whole of your student 200 orang kat depan ni boleh jadi customer Gojek. So why do you have to find only 100? Although SmartPLS boleh run. Untuk publish lah, I'm talking about publication. Dan untuk PhD student juga, cakap dengan your PhD student. My PhD student selalu cakap macam tu, dia tak nak collect. Dia kata, SmartPLS boleh. Kata, no. Unless if your sample is difficult to get. That's SmartPLS can run. If your sample is just a consumer, you should get at least 300, 400 for representativeness. Otherwise, you cannot publish.
Misalkan sampel banyak, tapi tadi ternyata formatif. Apakah ya kan di CBSEM kita tidak boleh melakukan formatif?
Iya.
Nah, misalkan tadi consumer tapi formatif, apakah kita pakai PLS? Ya. Jadi bukan hanya jumlah data, berarti ada juga terkait bentuk model mungkin.
The reason people use SmartPLS nombor satu adalah normality. Okay, dulu orang cakap small sample size.
Small size.
Sekarang tak boleh guna that argument. You can say that normality, that argument, and you can say that formative. Formative. There's a formative construct in it. There's a higher order dimension in it that has formative lower order construct or formative higher order construct. That's the reason we use SmartPLS. Tapi jangan guna perkataan the sample size is low.
Alasannya bukan karena sampel size-nya, tapi karena modelnya.
Modelnya kompleks.
Model baru. PLS. Itu konsep apa?
Items, new measurement.
Ya, ini.
New measurement, there are other the most what we call that protocol in coming up with new measurement. Dia ada test, retest, reliability, apa benda tu semua kan? Kan? Apa ya panggilnya? Constructability. Lepas tu ada satu lagi ya. Apa ya? Ada satu lagi validity that you have to go through. Test, retest, validity. Test, retest, validity adalah, and then you kena ada expert lah, you know, pilot test, pre-test. It's not only about SmartPLS. You have to go through all the protocol. All the procedure of coming up with a new measurement. Right? Coming up with a new measurement is a whole PhD by itself. It's a difficult thing. It's not an easy thing lah. Usually sometimes, sometimes people will use qualitative dulu. Dia interview orang dulu, and then tengok tim dia, and then come up with a items to measure construct, and then daripada items tu dia buat pilot test, and then lepas pilot test dia buat apa ya nama test tu yang contohnya kalau action as a items but you want to check whether this satisfaction ada relationship dengan loyalty, trust, all that variable yang sepatutnya ada high correlation atau high effect or relationship with satisfaction. Okay, you create satisfaction. You are creating satisfaction items, measurement items, but you would like to check whether these items nomological validity. Itu satu lagi. Nomological validity. Dia ada procedure dia. It's not about whether you can use or cannot use SmartPLS. Dia ada procedure. Boleh guna SmartPLS, Prof. Okay, ada lagi? Bila kita nak habis ni? Maknanya 2 hari boleh? 2 hari. Okay, let's continue ya. Any other question from the floor? Check tak ada ya? Okay. Yeah. Okay. All right. Okay. Aku tak nak move ni, my. Okay, kita slow sikit. Okay, this is different. It is. Okay. Okay, let us do this. Let's try and do this, ya. Berapa kita habis ni? Okay dulu ya. Baik. Oh, we are lunch. Saya confused. Pukul 11. In Malaysia pukul 11 pagi tau. Sebab tu bila Ibu Puspo tanya, kita start pukul 8 ya. Saya, no. Sebab pukul 8. Tapi kat sini pukul 4 dah subuh. Saya confused. Saya dengan anak saya, kenapa pukul 4? Okay, shall we go for a break and prayer? And then come back at what time? Jam 1, baiklah. Yeah. Yes, kita praktik, kita start SmartPLS punya uh, ya. Oke.
Oke, baik Bapak Ibu yang ada di ruangan maupun yang di Zoom. Insya Allah nanti kita akan mulai kembali di jam 1 untuk kita nanti praktek ya. Tadi sudah dari sisi metodologi ya, kita sudah banyak berdiskusi dan nanti kita akan coba praktek menggunakan SmartPLS. Kita akan break dulu dan mohon dipersiapkan sehingga nanti jam berapa? Jam 1 ya. Jam 1 nanti kita akan langsung praktek ya agar waktunya efektif. Demikian saya tutup sementara dengan ucapan hamdalah. Alhamdulillah. Assalamualaikum warahmatullahi wabarakatuh. Cek, cek.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, distinguished guests, professors, lecturers, ladies and gentlemen. Welcome back to the afternoon session. We hope you had an enjoyable lunch break and have returned refreshed and ready to continue today's workshop. Hadirin yang kami hormati, selamat datang kembali di sesi siang hari ini. Semoga waktu istirahat yang telah diberikan dapat menjadi kesempatan untuk beristirahat sejenak, sehingga kita dapat kembali mengikuti kegiatan dengan semangat dan antusiasme. Dan untuk hadirin yang masih ada di Zoom, boleh untuk dibuka dulu kameranya. Baik. Baik, apabila ada kendala atau apapun, silahkan diberitahukan ke Zoom chat. Dan as we continue our learning journey, we are confident that the remaining session will be provide further insight and practical knowledge on SmartPLS data analysis. Dan diberitahukan juga nanti akan di-share data-data di Dropbox yang akan jadi data untuk praktek hari ini. Untuk itu, marilah kita melanjutkan kembali workshop pada sesi berikutnya dan memanfaatkan kesempatan ini sebaik mungkin. Without further delay, I would like to hand over the session once again to our moderator. Kepada Pak Yusuf, kami persilakan untuk kembali memandu jalannya workshop.
Baik, terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Bapak, Ibu, dan semua hadirin yang ada di Zoom, kita akan memulai sesi 2 dan insya Allah kita akan coba praktek menggunakan SmartPLS. Mohon dipersiapkan softwarenya, dan kalau untuk data contohnya itu sudah ada di Dropbox tadi, silahkan di-download. Dan untuk mempersingkat waktu, kami persilakan.
Assalamualaikum semua. Okay, let's without further ado, let's continue ya. Nanti tak cukup masa pula. Jadi kita tak go through really the slides, right? Right. The thing that I would like to we are going to the model that we are going to do is, I thought initially we are going to do this, right? In the morning actually, but since we've already finished the morning session dan tak ada masa untuk buat yang ini hanya senang ini, yeah. Oh yeah, sorry. Okay, saya share screen sekejap. Terlupa nak saya share screen. Okay. Okay, this is the I'm sharing the slides again, right? Saya belum habis go through. There are 30 slides here dan saya tak go through lagi. So let me go through quickly in 1 minute, right? The model that we are going to do is this one, okay, cloud, right? In SmartPLS, and the data has already been shared in the Dropbox, in the folder called data and project, right? Before that, we have already done normality and complemented bias, okay? So I would like to go through a little bit about assessment of reflective management model. To recap, the thing that we have to report in our paper are this 1, 2, 3, 4, 4, okay, in this order, right? So we've already talked a little bit about normality and common method variance, but we have not talked about measurement model and structural model. Okay, so let's go through a little bit and then we do the practical. For measurement model, okay, this one, slide number 23. Okay, we need to do two validity checks. Dua check. We need to assess according to dua benda. Satu adalah convergent validity. Kedua adalah discriminant validity. These are the values that we need to report in our result paper in our paper in the result section. Right? Okay. So and the threshold are this. Okay. For convergent validity, we have to report outer loading. As you can see here, the outer loading according to HARE 2022, the outer load need to be 0.708 at least. But if we follow this, our construct will be botak. Itu botak. Semua kena delete kan? Jadi saya akan tengok 0.5 instead. Here. 0.5 instead. Those that below 0.5, saya akan remove. 0.5 dan 0.6 yang kita katakan sebagai borderline loading, borderline, that means half-half. We will remove only kalau kita nak improve AVE, which is average variance extracted, this one. Okay, so these are the values that we need to report. Okay, number satu, let me repeat, for convergent validity, we need to report outer loading. We need to remove outer loading that is below 0.5 and then remove outer loading that is below 0.708 if we need to remove because we would like to improve the AVE, average variance extracted, or we want to improve composite reliability or chromback alpha. Okay, then we remove a little bit. Okay, but for those loading that is below 0.5, remove without mercy. Do not think too much, just remove. Right, that is about loading. Okay, then we also have to report discriminant validity. In the past, we use Fornell and Lacker. In the past, but Fornell and Lacker criterion has already been debunked. Okay, if you would like to publish in a Q1 journal, you should not use Fornell and Lacker. If you want to publish in not Q1 journal, probably can. But our aim is Q1 journal, so go for HTMT. Right? Unless if the reviewer asks, where is your Fornell and Lacker, then you add. Right? So HTMT is by Hensler. Hensler et al. 2015. All right, Hensler, York Hensler. York Hensler is my examiner during my PhD, by the way. He's my examiner. Right? HTMT, okay, the HTMT, the value has to be below 0.85 and below, or 0.9 and below. Okay, so 0.85 is maximum threshold. This is for conceptually dissimilar constructs, like for example, engagement and loyalty. They are totally, they are not similar conceptually. If like action loyalty and cognitive loyalty, okay, they are still loyalty, but they are different construct, right? If you read Oliver 1999, Joseph Oliver nama dia, ke Richard? Richard Oliver, okay, Richard Oliver paper 1999 is a seminal paper in marketing if you want to talk about loyalty satisfaction. Okay, so dalam paper Oliver ada cakap that there's a 4 level of loyalty. So kalau you nak measure all these 4 level, they are still loyalty. So they are under conceptually similar construct. Right? Conceptually similar construct. So kalau conceptually similar construct, your HTMT, something happen or not? because of the internet, right? But that's okay lagi ya. Okay. Alright. Minta maaf ya, ada tergendala sedikit. Okay. So let's continue. For assessment, for assessing measurement model, these are the values that we need to report in our paper. Mesti, minimum. Okay, these are the values. So as you can see, convergent validity value dia lagi tinggi lagi bagus. HTMT value dia lagi rendah lagi bagus. Ya. Yeah. Okay, share screen tak share lah. Seperti biasa. Minta maaf. Okay, yes. Entire. Okay, right. Value-nya untuk sudah. Alright. So let me repeat. Convergent validity value kena lagi tinggi lagi bagus. Discriminability lagi rendah lagi bagus. For conceptually similar product, construct, the HTMT boleh naik until 0.9. Kalau lebih daripada 0.9, that means your construct doesn't have discriminant validity. Sama ada you kena combine the construct or remove one construct, or you need to do hierarchical SCA, hierarchical second order construct. Like I said just now, for second order construct, you need to have theory, you need to have backing, justification that sesuai. Dua tiga construct ini adalah sesuai untuk jadi higher order, lower order construct. Okay. Jadi kalau dia orang tak ada, discriminant. Okay. Alright. So these two things that you have to pass, convergent and discriminant. So kalau benda ni pass, you can move to structural equation modeling already. Kalau fail, you have to remove indicator. You have to check cross loading for HTMT. Alright. Saya ada sediakan kat sini ya. These are the what we call that, Hensler et al. Reference down here. Okay. Let's move. I don't want to explain about this because we are a bit late. So I want to go straight to structural equation modeling. Okay. Kalau pass, we need to go structural equation modeling. This is where we test our hypothesis. Tadi tu bukan test our hypothesis. We just want to see whether our the measurement really measure the construct or not. Really valid and reliable in measuring the construct statistically. Okay, that's the purpose of number 3, measurement model assessment. Okay, walaupun dia statistically okay, valid and reliable, nombor 3 tak semestinya dia bagus juga, sebab you need to make sure the face validity, you need to make sure the content validity, nomological validity. That is before the creation of a questionnaire. Once you created the questionnaire, you collect the data, there's no turning back, right? You already have the data. Betul ke tidak? You already have your data. So the only thing is to check convergent validity and discriminability. Yeah? Okay. So structural model assessment. So these are the things that you need to report. Number 1, the path and significance. Okay, whether your hypothesis is accepted or not accepted. Right? Okay. Nombor 1 adalah the beta. Standardized beta. Bukan beta yang dalam SPSS tu. It's not standardized. Yang ni standardized beta. Standardized beta. And then standard error. Okay. And then the T value and the P value and the low bias corrected percentile confidence interval up. Right? Paper yang tak Q1 usually they will do this and straight away P value. Ataupun dia letak ni atau letak star. 3 star, 2 star. Kalau Q1, you need to have all this. Yes, Becker 2022 punya paper. Why? Sebab, Okay. Sometimes when your data is besar, you will always find significant for everything if you only see p-value. Kan? But you cannot for bias corrected upper limit and lower limit. Kalau dia significant, maknanya there's no one in between, kan? Right? Kalau dia negatif, kalau standardized beta dia negatif dan significant, jadi low limit negatif, upper limit pun negatif. Ke sini, ke arah sini kan? Dia tak ada cost. Tapi kalau misalnya dia significant, sebab your sample is big, you akan nampak negatif positif. Bukan, kita cakap pasal one term. Apa ni dah? Ini. Dia ngantuk ni. Kan? Okay, so you have to give all evidence. Bukannya evidence pass coefficient dia besar dan star ataupun apa p-value. We have to give all. So sometimes when I review paper, I see all. You know, I tengok standard beta and I tengok PCI juga. Upper limit and lower limit. And sometimes upper limit and lower limit dia salah. Then you know sama ada dia ni, you know, tukar dia punya result or not. Okay, kalau upper limit and lower limit mesti tak boleh ada kosong in between upper limit and lower limit. Kan, betul tak? Maybe dosen Binti, Dr. Yusuf boleh explain a little bit better in terms of the statistical what happened. Perjelas tolong. Is it make sense not? Sense, okay. Okay, ini path yang significant. Ini satu that you have to report. Nombor 2, you have to report the F square. F square is effect size. Right? Okay. According to Cohen, effect size 0.02 adalah small. Size 0.15 and okay. So effect size ni ada kena-mengena dengan how big is your model, you know. Kalau your model is too big, macam semuanya ada sampai 74 arrow, of course the effect size akan menurun. Sebab effect size dia tengok semua variable dalam tu dan semua relationship. Okay. So kalau dia terpaksa compete relationship between each other, each of the effect size akan jadi low. Sebab dia have to compete, right? Okay. So the effect size. And then sekarang ni again to Shmueli. Okay, another paper. According to Shmueli, you have to report PLS predict because you've been saying that PLS is for prediction. Prediction meaning in the future. That is prediction. For MOS, dia tak predict the future. Dia just nak tengok whether the data can carry that theory or not. Is fit or not to the theory. Kan? Sebab tu dia ada fit kan? Okay. For PLS, on the other hand, dia nak tengok in the future. Dia predict tak? Predict in the future. Dia kena tengok in the future kalau dia guna the same questionnaire, adakah dia boleh predict sample lain in the future. That is PLS predict by Shmueli. Okay, Shmueli. Okay, the new one now is CVPAT. CVPAT is by Sharma and Lingard. Okay. Ini new one lah. I nampak dah paper Q1 yang ada CVPAT. Even saya pun dah start guna CVPAT. Okay. Yeah. So ini benda yang you have to report. CVPAT is entah lupa lah. Cross-validated ni. Saya ada tulis kat sini. Cross-validated predictive ability test. It's a predictive ability test that is a bit different than PLS predict, but the purpose is to predict as well. Yeah. Okay.
Predictive power.
Dia macam ni CV pad ni. Tunjuk. Publication. Okay. Ini publication saya di electronic market. Guna ada tak CV pad? Discussion control variable. Okay, tak ada. Okay, yang ni PLSPD as you can see. Ni PLSPD, table 6. Okay, PLSPD, you akan tengok the last variable. The dependent variable. The dependent variable is visit. Kita nak predict dependent. All this story is about predicting dependent variable, betul? So, PLS predict adalah ke atas dependent variable. Okay, so dependent variable ada 4 observe variable, 4 indicators. So you have to check all the indicators and you see the error. RMSE is root mean square error. RMSE. So you nak tengok error yang diproduce oleh PLS dan error yang diproduce oleh SPSS. LM is linear model. Linear model tu basically kalau you tak guna PLS, you guna Excel ke atau you tak guna structural equation modeling gitu. So you nak tengok error. So kalau error LM lebih rendah daripada error PLS, maknanya dia tak boleh predict. Kita nak error PLS rendah. That's the whole point guna PLS. Sebab kita tahu kalau guna PLS, error dia akan rendah. So macam mana nak tengok, nak interpret PLS predict is, kita tengok error RMSE of PLS and error LM and tolak, minus. Okay, kalau PLS lebih kecil daripada LM, result dia akan negatif. Ni PLS minus LM kan. Ni error. Error PLS minus error LM. Okay, benda-benda ni semua di mana nak dapat dalam SmartPLS. Kita nak kurang. Kalau positif tak bagus. Strong predictive power. That's the whole point we use PLS. To predict. Kau dah guna SPSS? Yes, tak. Yeah. Tapi kita nak negatif untuk PLS predict. Because kita cakap soal ini adalah soal error. Error kita nak kurang. Okay, yang ni PLS predict lah. Okay, for CV pad, yang ni saya tak berapa ahli sangat. Saya baru mencuba-cuba, dia baru sangat. Okay, ini satu lagi paper saya di also Q1 yang ini. Okay, also Q1. So yang ni saya mencuba-cuba. Okay, mencuba-cuba CV pad. CV whatever. CV pad kan? Okay, betul. Okay, saya mencuba-cubalah. Ni, saya report PLS predict as well as CV pad. Okay, I don't think I think you focus on PLS predict dulu. Okay, right. Okay, so okay, let's do this thing, yeah. Okay, this is about PLS predict lah. Okay, PLS predict as you can see here. Okay, Shmueli, according to Shmueli, tengok yang ini yang kecil ni. I don't know whether you can see, no? Okay, kalau nak tengok besar punya, you just download. Saya dah letak di sini. So untuk interpret PLS predict adalah you have to untuk interpret PLS predict is you have to check the error of PLS SEM and LM. We want PLS SEM error to be smaller than LM error. RMSE is error. Root mean square error. Betul ya? Okay. Yang ni apa? MAE pun error jugalah. Okay, apa namanya? Saya tak tahu. Something lah, okay? Saya belajar sampai sini saja. Saya dah tahu, boleh publish, saya just focus on RMSE. Okay? So, you can see here, Indicators, meaning what? Is items. Items of what? Items of the dependent variable. Bukan items of all variable. Variable yang paling akhir. Kalau variable paling akhir, you ada 2, 3, sometimes you have 2, 3, right? Variable. You have to check all 3 or all 2 because we are predicting that. Okay. So for example, none of the indicator PLS SEM error adalah rendah daripada LM, none. Tak ada. Semuanya positif, right? Tadi kita tengok sebenarnya negatif. Semuanya positif. Maknanya you tak boleh predict. Predictive relevance not confirmed. So what's the point of using SEM? Usually kan kalau misalnya you letak dalam okay, and publish dekat Q2 dan Q3, okay lah. Okay, try to hide it. Jangan nampak lah. Yang kalau dalam contohnya kalau you ada 5 indikator, right? Minority of indicator saja, contohnya dalam 5, maybe 2 atau 1 saja yang error dia lebih rendah kalau kita guna PLS SEM as compared to kalau kita guna linear model, which is SPSS or Excel or other, not structural equation modeling style, meaning kita boleh predict as low predictive power sebab only minority of the indicators. Okay, kalau majority of indicators, medium. Kalau for all indicators, that means high predictive powers. Okay, so as you can see here, obviously this is high, right? Mari kita tengok tadi kan. Mana pekot tadi? Okay, this is high because all. Okay, kalau hanya satu saja yang negatif, lain semua positif. That means low lah, low predictive power. Kalau half-half, medium lah. Kalau 1, 2, 3, majority pun medium. Kalau semua sekali, that's strong. Okay. LM is linear model. Okay. RMSE is root mean square error. Okay. This is what you have to do lah. Kalau you nak publish, the way you report, it has to be like this. Table kena ada macam ni. This is APA rule of table. Macam ni adalah APA rule. APA rule. APA rule means dia tak ada macam, bukan belang-belang, apa dia kata? Apa dia panggil? All that thing, it has to be empty here. Atas saja 2 dan bawah, atas 2 line dan ada note kat bawah. That is APA rule of reporting. We need to do that. Okay. Macam ni pun sama, APA rule of reporting. Kalau tak saya letak note lah, note. Tapi bila dah publish dekat electronic market, diorang actually take out the note. That means that is their style. So when you want to submit, you do APA rule. Lepas tu let them decide, the journal decide their style. So this table is very important to have table, and then figure usually kat bawah. Dia punya caption kat bawah untuk figure, nampak? Figure kat bawah, table di atas, table di atas. That is APA rule also. Okay, these are the things that penting kalau nak publish in good journal. Okay, alright, let's continue. Okay, bootstrapping is a little bit of bootstrapping. Alright, there are 3 types of bootstrapping. Basically, we use percentile. Right, there are percentile, there are bias corrected and accelerated bootstrapping. There are student types. We use percentile. Right? Why? Because Becker says so. Not me, Becker. And okay, this you can understand bootstrapping later on. Okay, these are effect size. Alright, macam saya cakap tadi, F square. Effect size. So effect size dia lain-lain ya untuk different. Dulu kita guna Cohen Chin dan Cohen. Okay. So 0.02 small, 0.15 medium, 0.35 large. You think now for moderation different. For mediation different. Dia dah lain so for moderation dia still guna F square tapi dia punya threshold dia makin rendah because memang susah kan nak dapat moderation punya effect size tu. So dia sangat sensitif, macam susah nak dapat. The sample has to be big and a lot of things dia ada lah dia punya rule for moderation, right? Jadi dia punya you know, dia punya effect size tu kena diturunkan thresholdnya. So that every time small saja. Right? Okay. So yang ni daripada siapa yang cakap ni? Hair et al. 2022. The book that I shared with you just now, the link. And then for mediation, kita tak guna F square, kita guna V square. Bukan V lah, apa ni ya? Lambda. Apa dah V ni? Okay. Epsilon kuasa 2. Okay, yang ni basically the standardized beta times standardized beta, you know, is standardized beta square. Okay, standardized beta of mediation. Okay, this one later lah. Okay, now let's go to SmartPLS. Do you have any question not? Before we go to SmartPLS. Okay, let's open SmartPLS. Right. Okay, this is my SmartPLS. I have a lot of other stuff here. Right. For those that have just used SmartPLS, it's going to be empty. Okay. So, okay, let's look at SmartPLS. Okay, SmartPLS, it has license, banyak lah. Okay, about. Okay, you can see that your SmartPLS is actually the latest version. This is the latest version, right? And then these are the creator of SmartPLS. So if you use SmartPLS, you must cite Ringlet at all. Okay, bukan Ringle lah, it's Ringlet. Okay, that's how to pronounce it. Ringlet. Ringlet at all to 2024. You have to cite Ringlet. And then apa lagi ya? Kat sini ya. About check for update, you can check for update preference. Okay, preference. Okay, you boleh jadikan di dark mode macam ni. Okay, saya tak boleh dark mode sangat sebab saya tak nampak dah. So saya suka orang muda-muda ni Gen Z suka dark kan. Saya dah Gen X. Okay, saya memang light. Tapi sometimes bila saya mengajar, they prefer black. Dia boleh nampak dekat screen kan. They prefer black. Tapi saya lah macam, mana tak nampak kan. Okay, those are under preference. So here your license, make sure your license is professional, bukan student. Professional. Okay, not student. There are other license, student. Student dia boleh baca hanya 100 responden. Dia tak boleh buat, macam-macam dia tak boleh buat lah. Okay, so that's why it's free. Okay, so we want professional. All right. And I've already given you the course license, right? License, I hope everyone has already, you know, activate their SmartPLS software. Okay. So dalam SmartPLS dah banyak dah sekarang ya. Dulu ada PLS SEM saja. Sekarang dia boleh buat regression, meaning SPSS lah, the LM model. Process, case, which can be done by SPSS. Okay. And then covariant-based SEM. Yang ni MOS. And then GSCA. Okay, ni Gaussian Copula ke apa? Is it Gaussian Copula? Yeah, Gaussian Copula, right? Yes, Gaussian Copula. Dan ni kalau nak tengok endogeneity, if I'm mistaken. Endogeneity. Okay, saya pun baru berjinak-jinak. Ya. CBSM, masa saya buat PhD, saya guna CBSM, MOS. Okay, right? So we are going to do this. PLS SEM. So first you need to create workspace. You don't have workspace? Do you have workspace? No. So you have to create workspace. Okay. Go to new workspace. New. Okay. I have recent workspace a lot. My workspace. Okay. Now you guys need to new workspace. Okay. Create workspace. Okay. Workspace can be anywhere, can be in desktop, but you have to remember lah, where your workspace. You can put in the desktop or document or in a folder. So I would like to put here, in this folder lah. Okay. Ataupun folder SmartPLS workshop. Student. Okay. Ya lah, SmartPLS workshop 15 Julai. Okay, saya letakkan sini. So saya new folder, you have to put new folder. Name the folder. You can name the folder your husband name, boyfriend name, girlfriend name, semua boleh. Tapi please remember the name. Okay, like me, I just want to do UPI. Okay, so I remember that this is SmartPLS UPI that I did. I'm doing with UPI. Okay, so I create. Open. Once you create, open. Okay, semua boleh ikut ya. Tak kena laju sangat. Open. Mana Rahim? Okay, Rahim. Tolong ya Rahim. Tengok semua orang. Pastikan diorang buat. Okay. Okay. So sekarang ni saya punya work, saya dah di dalam workspace tersebut. Nama workspace saya UPI SmartPLS ini. Okay, cuba check. Here. Check everyone need help or not. Okay, yay. Ada soalan ke siapa-siapa di online?
Yang di online, apakah ada kesulitan? Kalau ada kesulitan,
Yes.
nanti silakan chat aja ya. Oh, jempol. Oke.
Okay, ngam. Okay, next, what we're going to do is the cloud, right? The cloud, this one.
Cloud. Okay.
The cloud model, this one. Okay, this one. So the cloud model, as you can see, it use DOI, diffusion of innovation theory. Diffusion of innovation theory, dia ada 5 main variable, which are tribability, relative advantage, complexity, visibility, and compatibility. Okay, basically these are using that theory. 1, 2, 3, 4, 5. And then kepada adoption of cloud computing. Okay, so let's do that. And these are the items of measuring diff construct. Okay, and the hypotheses, there are 5. Either positive or negative. So here there's only one negative effect. Of course, the more complex what you call that, a software or cloud computer or whatever new technology product that you want to use, the less tendency that you're going to adopt it. Okay, so the more relative advantage that you perceive of using that new product as compared to the product that you have used before for this to get the same solution, the more your tendency to adopt that new product. That is relative advantage. Triability, the more that you feel it can be tried for free. That's why you can see Dropbox, all these new even Claude, or all these new AI, ChatGPT, you can try for free, right? Yes, because of this triability. The more that your product or your technology, new product can be tried, is perceived to be able to be tried for free, the higher the tendency for the user to adopt the new product and so on. Visibility can be seen, observed. Okay, bukannya tersuruh, right? Compatibility is compatible with your lifestyle, with your work, compatible with your Gmail, for example. You can see that a lot of software now can be registered using your Gmail, right? Sometimes with the Facebook, you can register, right? Itu untuk increase compatibility. Sebab tu sekarang ramai orang guna Gmail. Dulu banyak orang guna Hotmail, Yahoo. Sekarang ni semua dah move to Gmail sebab compatibility senang. Nak register pun, okay, do you have Gmail? Do you want to register using your Gmail? Yes. Kan? Itu compatibility. Yeah? So ini adalah teori daripada Rogers. Nama dia Rogers, apa nama dia? Saya tak tahu, saya lupa. Nama dia Rogers lah. Tapi first name dia saya lupa. So Rogers 1985, if I'm mistaken. Nama teorinya adalah Diffusion of Innovation. DOI. Okay, let's do this, yeah. So let's go to the SmartPLS. You have already your workspace and you are already inside your workspace. So what you do is we have the data. You want to import the data in. Okay, so go to SmartPLS, files. All right, you can go to the file and project. Okay. No, we have to create project first. Okay, click new project. Name the project. Maybe I want to name as Cloud UP. Okay. Right, create. Okay. Once you have created, you can see there's two links here. You have to import data first. Let's import the data. I've already given you data. Okay, import data, click here. So pergi dekat folder data and project, and then you can see there are data. Data CSV, SAV. Okay, SmartPLS dia boleh baca Excel, dia boleh baca SAV. SAV is SPSS. CSV is macam Excel lah. Okay. Dia boleh baca Excel, even dia boleh baca text also. But I usually like CSV. Dua-dua lah saya suka. Okay, kalau daripada SAV lah. Okay, boleh juga. Okay.
Saya sudah simpan di chat juga. Tadi sudah saya downloadkan. Saya simpan di chat. Kalau misalkan Bapak Ibu yang di Zoom bisa di-download di chat box untuk datanya.
Ya, ada yang tak boleh ya. Ada yang mungkin diorang hadir the afternoon one, dia tak tengok. Chat yang awal lah.
Oh iya, tadi saya sudah kirim.
Sudah. Okay.
SV-nya saya masukkan.
Yeah. Okay. So you can use anything, yeah. So I'm going to use SAP lah. Okay. Alright. Okay. Boleh ya ikut. You click that SAP and then you check lah. Okay ke tak? So hopefully semua matrix lah, matrix. Kalau dia ada tak matrix, tukar kepada matrix. Walaupun dia binary ke apa-apa ke, you tukar je kepada matrix. Okay. Dia akan jadi binary lah kalau you masukkan demographic. Okay, dia akan jadi dekat sini apa? Ordinal or categorical. Dia automatic. Right? Kalau you masukkan demographic macam gender ke, income ke, yes. Right? Tapi saya nampak tak kira lah gender ke apa, saya akan letak semua matrix, senang. Dalam SmartPLS ni. Okay, sebab demographic profile kita buat dalam SPSS anyway. Right? Demographic profile punya tables memang kita buat dalam SPSS. So there's no reason why you nak ni ya, you just buat matrix, senang kalau nak buat control variable. Okay, so you can see here there's one TR1 ni, RA. Okay, ada one problem here. Okay, we'll see afterwards ya. Okay, buat RE2, RE3, RE4. RR, what ada R? Ada 4. Oh. Okay. Ini TR1. Ini adalah TR1, yes. Tapi dia reverse coded. Reverse coded. Reverse coded. Tapi inilah TR1. Okay, kita tengok balik kat sini ya. Triability ya. TR1, TR2, TR4, right? Okay. So dia macam ni. TR1, TR2, TR3, TR4. Sebab dia reverse. That's why dia macam ni. Yeah? Okay. There are marker variable also be collected. Okay, marker variable. Okay, let's import ya. Import. Okay. Okay, you can see there's raw data here. Okay, go back. Back. Okay. Right, kita dah ada data di sini, 150. Sekarang ni tugas kita adalah to create the model. Okay. Okay. Right. Okay, Rahil. Okay, Rahil. Okay, so create model. Okay, click. Okay, you can see ya, ada banyak ni ya. You can choose also. Nak PLS SEM ke, regression ke, tapi kita nak buat PLS SEM lah. So click PLS SEM. Okay, click. And then you letak model name juga. Maybe kita copy from the top, Cloud UPI also. Okay. UPI, okay? All right, so now this is what happened. Okay, you can see here all the data and the items, observe variable here. Right, and then there's an empty canvas here that you can draw. Okay, all right, let's draw now. How to draw? Easy, easy peasy, lemon squeezy, we just, drag, yeah? Okay, drag in, Okay, let me close this first. Drag in. Mana tadi? Okay, drag in. All right, first we drag tribability. Okay, tribability, bismillah. Tribability daripada nombor 5, shift, select, and tarik masuk. Release. Kalau you happy, you boleh release lah mana-mana. Kalau you happy, okay, I nak release here. Okay. Alamak, sorry Excel. Dia alpha lah pula. Okay. Macam ni kan, so ini adalah tribability, right? So kita nak tukar nama ni. Kita klik alpha ni. Kita nak tukar nama. Klik alpha ni. Okay. Kepada trialability. Okay, apply. Okay. Okay. Okay, so saya nak drag RA pula. Okay, RA, right? This one, RA is relative advantage. Okay, drag in. Relative advantage, right? Betul? Okay. And then we drag first, everything. Complexity. Ini complexity, right? 5. Betul, 5? 5 items. Complexity. Complex. Apply. Okay, complexity. Yes, 1, 2, 3, 4, 5. Okay, now CCA is cloud computing adoption. CCA. Yeah. Okay, let's drag CCA in. This is the dependent variable. Okay. Okay, another one. Apa lagi? Satu lagi. Tribability, visibility. Right? Visibility, VIS. Okay. Visibility. Okay. Okay, tak? Let's wait for a bit for people online. Who's it? Okay. Okay. Okay, we are still in select mode. Kita boleh klik kepada connect, kita boleh klik macam-macam here. Okay, we are in select mode. Select means kita boleh move around. Okay, so we want to arrange lah. Arrange like this. Arrange like this one. Okay, cloud computing is the DVD. Okay, tribability, relative advantage, complexity, visibility, and compatibility. It's compatibility. Yeah. Do we bring in compatibility? I just remember. No. Wrong. Salah.
Oh,
Okay, CM is actually compatibility, bukan complexity. Okay, so let's change this. Compatibility. Apply, and then this is complexity, CX. Okay, so let's now arrange this cantik. Okay, move to connect mode. Click this and then connect. Yeah, connect is like you have to make sure that you are in the connect mode. Click and drag. Click and pull. Pull sampai ke destinasi dulu. Baru release. Jangan pull kat sini. Pull kat sini sampai minggu depan pun tak ada apa-apa berlaku ya. So you have to pull and then reach first. Destination. And then release. Sama, visibility pun. Complexity. Complexity ada dua. Oh, okay. Ini adalah compatibility ya. Oh, okay. Faham pun. Oh, yang ni. Nampak tak caption in report nanti dia tidak jadi compatibility. Tapi di sini adalah sepatutnya ada dua tak cakap. Bukan dua. Okay. There. Alright. So complexity di mana? Compatibility di bawah ya.
Complexity di bawah.
Okay. Kita nak compatibility. Okay. Kita nak tukar compatibility di sini. Kita pergi ke select mode. Yang ini kita tak boleh move around. Kita select baru boleh move around. Contoh. Okay. Kita select baru boleh move around. Stability, relative advantage, complexity. Okay. Complexity di sini. Visibility di bawah. Contoh. Betul kan? Ability, relative advantage, complexity, visibility, compatibility. Okay. Betul lah. Okay. Dan saya pun nak move juga yang ni. Tak suka lah, tak cantik. Dia punya item ni saya nak move ke atas. Kita masih select ya. So kita move ke atas. Nampak tak yang ni? Kita boleh move ke atas. Okay. Macam tu. Okay. Move ke tepi. Okay. Actually, you can already move around a lot already. Okay. 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 Ngam. Kesemuran dan loss. Yeah, select. You have already in the select mode? If select, then you should be able to move. Okay, you select and then you have to move. Did you move or not like this? Look. It's not moving. Okay, try connect. Try click connect and then click select again. Okay, let me see then. Okey, maaf ya. Okey. Okey, kami tengah daripada sini kan? Daripada sini kami tukar, saya telah tukar coloring so that we can export into our Word document for reporting, for reporting for Q1 or thesis. Okay, daripada draw sendiri, okay, lukis, kita boleh lukis terus, kita boleh copy and paste terus daripada export terus daripada SmartPLS. Macam saya guna tadi lah. Okay, macam yang saya buat adalah select all, tukar warna. Mula saya tukar warna. Okay, saya tukar kepada warna hitam sebab warna hitam putih lebih baik untuk publication. Okay, and then saya right click, export as image, export, and pergi ke mana tadi? Word document hilang dah. Hilang dah Word document. Okay. Okay, tapi ini dokumen lain, silap. Tutup ini. Okay. Satu lagi Word document. Ini. Okay. Okay, tutup ni. Okay, apa yang saya buat? Okay, saya boleh paste. Saya boleh paste, kan? Soalnya saya buat macam ni, saya tak paste terus macam ni. Saya akan letak dalam table supaya dia tak lari. Saya akan letak table. Saya buat table dulu. Okay, insert table, one table like that. And then baru saya paste dalam table. So, yang ni saya buang. Saya paste dalam table macam ni. Okay. And then saya akan keluarkan dia punya ini. Dekat sini. Saya akan take out dia punya border. Macam tu. Tukar border. Macam tu. Tapi dia tak lari lah. You know it's in the table. Kalau tak, dia akan kiri, kanan, ke atas, ke bawah, tiba separuh. Kan? Okay. This one you need to have caption, right? Insert caption. What is it? Figure. It's not a table, it's a figure. So, apakah figurnya? Conceptual model ataupun research framework. Ya? Yeah? Okay. Ngam. So, kalau you letak figure je, dia akan terus ke bawah. Sebab you guna caption tadi. Okay? Sebab kita guna caption tadi. Okay, caption. Kan? Kita guna ini tadi. So, kalau kita letak figure, dia terus buat. Okay, kat sini dia ada banyak figure, table. So, you can change lah kalau you nak table. Kita guna figure. Okay? Alright. Okay, ngam. Okay, let's continue. Okay, so let's run now. So, apa yang kita nak tengok? Kita nak tengok measurement model assessment dulu. Kita nak tengok apa tadi dalam kita punya okay. Kita nak tengok, kita kena start nombor berapa? Nombor berapa kita kena start? Nombor 3. Ini kan? Kita kena buat ini semua. Ini adalah reporting yang kita kena buat. Tapi kita kena start dengan nombor 3. So, kita start dengan nombor 3 lah ni. Measurement model. This is what we're going to do. So, what is measurement model? Measurement model is maknanya gini. Okay, assessment of measurement model. Apa? Reflective. Bukan formative. Reflective. Ya, reflective masalah. Okay. So, kita kena cari loading, kita kena cari reliability, kita kena cari value alpha, okay, kita kena cari value AVE dan HTMT. Okay, that's what we're going to do. Okay, kita perlu lihat, perlu assess whether they pass or not, pass. Okay, convergibility, pass or not. Discriminability, pass or not. Okay, so let's go. Okay, calculate. Okay, calculate boleh dibuat di sini juga. Boleh buat di sini juga. So, calculate PLS SEM algorithm. Okay, calculate. Kat sini, don't click, take it out. Okay, don't click. Okay, sebab kalau dia klik, dia akan terus ke report. I don't want that. I want to see the picture first. If I want to see report later on, I will click on report. That's what I do. Because I like to see pictures. Right? Okay. Start calculation. Jangan tukar apa-apa. Start calculation. Dia calculate dalam kurang daripada 1 saat. Okay. Right. So you can see here, these are all loading. Because these are all reflective construct. So these are all loading. Okay. So apa yang kita perlu tengok? Loading kena bawah 0.5 kan? Bawah 0.5 semua buang. Okay. So we have to examine all the loading. Ada tak? Yang ni kena buang. TR3 kena buang tapi kena tulis lah. Okay. Bila you buang TR3, you kena tulis yang you dah buang TR3. You kena report. TR3 remove. Why? You remove because low loading. Okay, remove. How to remove? Right click. And delete.
Delete.
Just delete. Okay. Right click, delete. Okay. Alright. You guys, saya di-calculate automatically.
Oh, iya. Kalau saya tidak.
You tidak kan?
Yeah.
You guys
Calculate.
calculate automatically tak? No. Okay, how to do that? Here.
Sebelah kirinya
Here.
recalculate. Ya, recalculate automatically-nya diaktifkan.
Jadi dia automatically. Tapi tak apa kalau tak pun you buat lagi sekali.
Calculate lagi.
Yes. Nampak ni? Calculate automatically.
kembali mak.
Okay.
Iya itu juga.
Yang ni pun rendah juga ni ya.
Rendah.
Okay. Previously dia tak rendah kan?
Rendah. Previously rendah.
Ya.
Iya.
Saya tak ingat. Boleh tak? Tengok balik. Oh, previously pun rendah
Rendah.
TR3
TR3 and TR4
rendah dulu ya.
Ya.
Oh ya. Okay. We have to remove these two. We left only two, which is not good. But yeah, that's what it is. Okay. So we have to delete this. We have to delete this. Kalau dia improve pun sikit lah. Maybe you can retain this dekat 0.5. Look at the AVE. AVE dah pass. Nampak tak? What we would like to see is loading AVE, right?
FDE.
We got to see AVE, right?
Yeah.
Okay. AVE must be more than 5. 0.5. 0.5 and above. Okay. Kalau tak fail. So how to check the AVE is by hovering your cursor on the latent variable and then you can see this box.
Di mouse over ya.
Just hover.
Ya. Mouse-nya dideketin ke bagian variabel latennya, nanti akan muncul result.
Yes. So you can see AVE 0.590. Right? And alpha is 0.8. Composite reliability row C 0.8. Good. So dah pass kan? Jadi maybe kita boleh retain lah ni. Takkan nak ada dua saja kan botak. So kita retain. Walaupun dia 0.5, kita retain. Sebab dia dah dekat. Ya, cara total.
Masih bisa dipertahankan.
Ya, masih bisa. Sebab kalau dia punya AVE itu rendah, then we need to remove that. Tapi AVE dia sudah pass. 0.590. Ya? Okay. Tinggal 2 lah. Kalau you ada lebih lagi, okay.
Kalau tinggal 2, rendah.
Okay. Okay. Next will be, ada lagi. Okay, yang ini. Complexity pun
Complexity
rendah,
ada CX5.
Betul? So remove. Right click. Delete. Okay, CX4, right? Okay. Lain, yang ini pun. Okay.
Visibility.
Visibility 4, remove. Delete. And then, yang ini okay.
Okay.
Yang ini okay ya.
FPA-nya Mbak.
Ini adalah loading ya, loading. which is correlation actually. Loading, okay. Okay. So let's look at the other, yang ni lah, the AVE dan, okay. Susah lah macam ni. Tak nampak. Okay, sini lah saya buat. Ya, saya buat macam ni. Okay. Ni. Okay. AVE mesti lebih daripada 0.5. Okay. AVE lebih daripada 0.5. Okay. Composite reliability lebih daripada 0.7. Okay. Chromback alpha. Okay. Chromback alpha agak rendah. 0.699 tak apa. Okay. Let me tell you that people, we don't need to report chromback alpha anymore. We only report composite reliability row C. Row A adalah untuk consistent PLS. Consistent PLS is another PLS where dia macam covariance based a bit, where we report the feed, the goodness feed index and all. That is consistent. So sekarang ni we report row C. Okay. So semua pass kan?
Pass.
Okay, semua pass. Alright, yang ini pass.
Pass.
Okay, yang ini pass. ABE masih 3.5 and above. Pass.
Pass.
Walaupun ada yang rendah. Rendah. Okay, tapi dia masih pass. Okay, kita retain. Yang ni pass. Pass. Okay. Yang ni pass. Okay, pass. Pass. Okay, so kita dah pass apa mana? Kita dah pass the first stage, which is management model assessment, right? Okay, jadi kita arrange lah little bit, biasa cantik sikit. Pergi kat sini, masih di select mode. Okay, go up like this. Okay, dia akan arrange semua. Okay, so value ni, what value is this? R square, right? Yeah. So you can see only this latent variable has R square. Kalau you hover, ni doesn't have R square, this doesn't have, all others doesn't have. Okay, because this is endogenous construct. Okay, endogenous construct where there are arrow pointing to it. Yang ni semua tak ada arrow pointing to it. Tak ada. So there's no R square. Okay, so here automatically dia akan tunjuk R square. Automatically. But we don't care about R square now yet, because this is not structural equation modeling yet. This is measurement model assessment still, that first stage. Okay, so we don't really care about R square. We care about AVE, we care about composite reliability now. Right? So we don't want this, we want to show composite reliability instead. Okay, pergi dekat sini. Okay, here, construct. Construct. You click this one. Okay, R square, right? Okay, we don't want R square, we want AVE. So you can report like this. Yeah, so you can report like this, you export as image like that, you export again. Okay, go to our Microsoft Word again. Okay, maybe page break. And then insert table again. Okay, and then insert this here. Okay, and then insert caption. So figure still, bukan table. Figure measurement model assessment. Okay, ni measurement model assessment. Model assessment. So kat sini kita nampak the loading and the AVE. Maybe you can put note down here. Note the values. Just values in the circle or in the construct, inside the circle, okay? Inside the circle, okay, are AVE value, AVEs. Maybe you boleh buat macam ni juga, ya? Okay. Cikkan dia. And then yang ni. Okay. And then you can also say TR3 and CX4 were removed to improve due to loading. Loadings and to improve the AVs.
CX5 actually.
Oh, CX5 pun CX5 also. Kan? Oh, we retain. We remove.
CX4 is retained. CX5.
We remove also, yeah?
And FIS4.
FIS4, okay, it's more. Okay, yeah.
Were removed. CX5, yeah. CX4 is retained.
The Arab
CX4 is retained.
retain,
Yeah.
yang dibuang. The Arab apa yang terbuang tadi?
TR3.
TR3, ya? Okay, 3. Okay. TR3.
Were removed. Sini measurement loading.
Okay. Yang ini basically research framework ni usually you will have a hypothesis development section before you show research framework. Okay, in a paper you will have hypothesis development section, literature review before methodology. You show this, and then you will write methodology, right? Blah 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 blah, and then result, right? Okay, result, step 1 will be measurement model assessment. Okay, this already result lah. Okay, measurement model assessment. Okay. And in step 1, stage 1. So in measurement model assessment, you also have to report a table. So let's look at the report. Okay, open full report. Okay, let's start again. Open full report. Okay, click down there. Open full report, and then close this. Okay, so here construct reliability and validity. All right, basically these two are very important for measurement model assessment. Construct reliability and validity and discriminant validity, HTMT. Okay, so you click here and then you will see this. Okay, right, these are the result, right? So copy to Excel or Word. All right, open your Excel. Usually this is what I do. I settle dalam Excel dulu. Okay, copy here to Excel first. Just copy like this. Okay. No. Wait. Copy here. Jauh sikit. Jauh sikit copy. Okay. So I want to take the loading. Loading. Okay. Look for the loading. Is it auto loading? Auto loading. Yeah. Okay. We want this loading. Okay. So the loading. Oh, yang ni rendah lah juga tapi tak apa sebab the AVE is already strong, right? Okay, so you can see here, dia ikut alphabetical order kan. So yang ini walaupun TR1 tapi dia start dengan R. Jadi dia pergi dekat relative advantage. You have to arrange lah afterwards. Okay, so what I'm going to do is copy to Excel and Word. This loading, this one. Okay, here, again, let me repeat. I go to auto loading. Okay, you get this. Okay, click auto loading, copy to Excel, copy the whole thing to Excel, right? So you can see that's a little bit different here because this is TR1 kan? So dia bawah TR1, TR1, TR2, TR3 kan? Here. So this sepatutnya together, right? Tapi sebab dia alphabetical dia R, dia pergi masuk bawah R. Okay? So you need to arrange in Excel. Okay, just now I already copy to Excel, right? So I open my Excel and copy about here. Okay, I copy about here. So, okay, so now what we want to do here is like this. We want to do this. This one. This is what we want to do. We want to have construct, we want to have item, we want to have loading, lambda, and then this is what? S.Si ni apa benda? Lupa dah. Variance inflation factor. Oh, it's not supposed to be S.Si actually. Okay, we don't want to have this. It's okay. Yang ni extra lah kalau nak ada. We want to have row C, maybe alpha score, from by alpha, dan AVE. Okay, that's what we're going to do. So, we already have the items, we already have the construct, we already have the loadings, and we already have this row C, AVE, and combat alpha. Okay? Okay, because why we have? Because we've already copy paste here, right? We already copy paste here. So now we want to arrange. So how to arrange? Okay, this is what I always do, right? I copy and paste cloud computing here. Macam tu. Compatibility mana? CM kan? Okay. Okay, sini. Okay, you guys can just copy and paste. Or cut and paste. Okay. I guna MacBook, I drag je. Nampak tangan ni? I drag terus. And release. Okay, okay. This one is a little bit different. Because it's supposed to be here, right? This one, RA1, TR1, yeah? It's supposed to be here, TR2. So I'm going to make a new, insert a new row. Okay? Insert. New row. And then ambil yang ini. Semua sekali. Semua sekali. This is how I do, okay? You guys can just copy and paste. I drag to go. And then delete this. Delete. Delete this row. Okay, delete. Okay. Right? So, yang ini adalah relative advantage, right? Okay, so here, I drag relative advantage here. Tribability. Drag down. Here. Visibility. Kat bawah ni. Okay. Okay nak? Is everybody okay? Ya, maybe kita tunggu sekejap. Mesti dah.
Yang di Zoom, apakah aman yang di Zoom?
Alhamdulillah. Okay. Alright, kita nak buat apa Kita nak buat ini. Kita mahukan kita dah ada items, kita dah ada construct. Sekarang ni kita nak make sure that the loading dalam satu barisan. Okay? So sekarang ni loading bukan satu barisan, right? So yang ni adalah construct, right? Construct. Okay? Yang ni adalah items. Yang ni adalah loading. Lambda, loading. Okay? Dan kita nak letak all this here. Okay? Now we want it to be satu barisan. So how to do is copy and paste balik. Macam tu. Kan interesting ni. Okay. Ya. Sudah ya? Alright. Sekarang ni apa lagi kita perlu? Kita perlu row C AVE. Okay. So yang ini. Row C dan AVE. Okay. Mari kita ambil. Letak dekat sikit. Tak dekat-dekat sikit. We would like AVE. Okay. We want, okay, yang ini row, yang ini dia ada row A dan row C. We want row C. Row A delete, remove. Nanti kita confuse. Mana remove ni? Delete. Okay. So we want these three okay already. These three okay already. Okay. So cloud computing. Yeah. Kita nak dia kepala ni label ni drag. Pergi sini. Betul? Okay. Ni combat alpha, row C dan AVE ya. AVE kita boleh just letak AVE macam ni ya. Okay. So yang ni cloud computing kan? Cloud computing ya, cloud computing. Kita nak drag again. Okay, kita nak drag again all these three. Drag here. And then compatibility, drag here. Tak payah drag, copy and paste also can, or cut and paste. Kalau tak boleh nak drag. Complexity, here. Relative advantage, here. Tribability, here. Okay, visibility, here. Okay, okay, let's remove this. Delete. Okay, yang ini adalah row C. Kita tukar kepada row C. Yang ini alpha score. Okay, alpha score. Maybe kita boleh letak alpha saja. Okay. It's smaller bit. Okay, terlalu kecil lah. Okay, okay. Okay. Okay, is everybody all right? The online? Okay ke? Suara ada lagi ya? Suara ada lagi. Aman, okay. Adakah semua aman di online? Di alam maya? Maybe we wait for a while, 2-3 minutes. Let them drag. I'm sure dragging is quite. Okay. Okay, for APA rule, everything need to be 3 decimal point. Nampak 0.58 is not 3 decimal point. Okay. How to do is you drag everything lah, kan? Tak do 2 decimal point, right? You put kat sini. Okay. 3. We need 3 decimal point, bukan 2. 3 decimal point. Okay. So, can you see that some are green, some are red, right? Betul tak? Okay, sebab kita yang baru punya SmartPLS 4 ni, dia memang color coding. Right? Supaya orang-orang yang tak pandai statistik macam saya, boleh nampak. Sudah nampak. Kalau merah ni, yang ini dia ikut threshold apa? Loading. Threshold hair. 0.708. Ini threshold ini ya. Macam tadi. Ini. Hair punya threshold ini. Kalau bawah daripada 0.708, dia akan jadi merah atau hitam. Kalau borderline hitam, and then kalau bawah sangat, macam ini bawah kan? Dia jadi merah. Okay? Sama juga dengan ini ya. Alpha score must be 0.7. Kalau bawah per threshold walaupun 0.699, dia akan jadi merah. Okay? So, yang ni pun merah ya. So, untuk orang-orang yang tak pandai statistik, boleh tengok color. Kalau you ada color blind, itu tak boleh tolong lah. Okay, so yes, so but we don't report like this color. We don't report color in the thesis or in our paper, right? So you want to change the color, betul? Okay, change lah the color. Change the color. the color equation modeling. Okay, so yang ini adalah sorry, belum selesai lagi. Kita ada discriminability, sorry. Yang ni convergent validity. Okay, convergent validity. So convergent validity settle. So we want to copy this and report in our paper here. Okay, we want to report here and just copy and paste. Paste. Right? Maybe if like this, we put like a insert page break so that it is in one page like this. Yeah. Okay. Okay, close that. So what we want to do, we want it to become like this. AP, right? Okay, APA rule. So go to Microsoft again. Nampak ni? Ini table, right? So just click here. Go to table layout. Auto fit semua okay. Kalau table dia panjang sangat, then you can auto fit window. Sekarang table dia okay, right? Tak panjang, tak melebar. Go to table design. Choose list 6. Let me see. This one. Choose this one. List table 6 colorful. Okay, click. And then shading. Take out shading. Make sure there's no shading. No color. Okay, this is APA rule. Okay, then you need a caption. Now the caption is not figure. Caption is table. Right? So table 1 is convergent validity assessment. Okay. Okay. So also we have to write note here. Okay. apa note kita tadi? Okay, mula note kita AVE is average values extracted. Apa-apa yang kita guna abbreviation sini. Abbreviation we need the full name, average variance extracted. Okay. And also we need to write a report, a very concise report that we have removed some of the items due to low loadings and because we would like to improve AVE. Okay, like this one. Like this one. Okay, maybe we can just copy. In APA rule, the table need to be independent. Okay, when you read a table, it must be like, apa orang kata tu? Semua informasi sudah ada. Dia tak payah kita scroll up, scroll down apa ya? Apa ya tak ada. Sebab tu kena ada note. Okay? So that kita tak payah naik turun. Okay, this is your convergent validity assessment. Okay, next will be discriminant validity. Okay, next will be discriminant validity, right? Okay, the next one is okay. Discriminability, mana tak ada. Kita perlu discriminability yang ini. Kita sudah selesai convergibility. Sekarang kita perlu discriminability, HTMT. So the next value that we have to report is HTMT. Okay, go back to your SmartPLS report. Still under PLS SEM algorithm. Go to HTMT, which is discriminant validity. Discriminant validity. Still under quality criteria. Okay, here. Discriminant validity. Okay, click discriminant validity. After you click, you straight away can see already. HTMT. And HTMT value dia kena rendah. Tak boleh lebih daripada 0.85. So you can see all green. So dia memang pass, semua pass. Okay, so you copy again, go to your Excel, paste. Okay, so how to report APA rule? Usually how you report HTMT is like this, yeah? Make it big a bit. Okay, like this. Same, it has to be 3 decimal point, huh? So maybe we change this to 3 decimal point. Okay, right? So here you have to put 1 kat depan. 1, 2, 3, 4, 5, 6. Okay. And then ke atas ni pun satu-satu, right? Ni nombor 1, right? Ni pun nombor 1. So tukar pada 1. And then compatibility 2. And then 3. And then 4, 5, 6. Okay, this is APA rule. Okay, you can see this pair. Dia pair kan? Nombor 2 dan nombor 1. Nombor 2 dengan cloud computing, yes. Discriminant. 2 construct ini discriminant. And then this pair and this pair and this pair, right? Okay? Okay. So, any question?
Ini ada yang tanya, saat copy paste dari SmartPLS ke Excel angkanya berubah menjadi banyak. Oh iya. Jadi di SmartPLS ketika di paste ke Excel itu jadi angka full, desimalnya ke belakang banyak. Ya, jadi tadi solusinya itu di blok di Excel-nya berubah.
Tak berubah.
Mm-mm. Kayaknya jauh ya. Kalau biasanya pembulatan ya. Coba coba formatting di Excel-nya ya. Khawatirnya bukan number. Di kolomnya number atau general. Ya, ketika di paste angkanya berubah. Mungkin type-nya bukan. Hah? Oh, coba. Ah, oh iya bisa juga berubah sih di MacBook. Tapi di itu Ezlika oke. Coba paste-nya value 192. Padahal di sini udah 77. Angkanya berubah. Nah, sini baru namun, baru namun juga. Ini berubah. Sama, sama juga sama. Jadi gini ya. Padahal di sini betul. Betul. Ini sama, tapi ketika di paste di Excel, Saya langsung ke Word-nya. Tapi kalau ke Word betul. Kalau ke Word betul.
Terus saya pakai Excel tadi. Oh, CCA and
Berubah. Tapi kalau saya paste di Word betul.
compatibility.
Rapi. Ya.
Oh,
Ya. Ada juga baru. Ah, ya benar. Ya betul betul. Oh ada rendering makanya ada mungkin ada perbedaan. Nah, tapi kalau di sini betul benar. Kalau di apa? MacBook ya. Berubah ya? Saya tadi nggak notice. Yang di atas ya. Ini berubah juga yang convergent validity. Saya nggak ngecek. Oh iya. Coba convergent validity. Tapi caranya tadi berarti save ke Excel all
ya.
some bugs. Nah, nah, koma. Ah, gara-gara itu formatting. Oh, oke, coba saya rubah formattingnya. Koma, setting koma kayaknya. Kemungkinan itu. Tapi tadi kalau di ekspor semua ke Excel sih aman tadi. Oh, oke, itu. Eh, Oh, paling gini cara. Ini number harusnya harusnya number ya, number. Oke, apa? Sedikit ini.
Oke.
Oke,
Oke.
lanjut lagi.
Oke, then. Okay. Then I'll,
Well, eh, Baik, kita break. Oke, kita break dulu 5 menit biar kita kembali fokus. Nanti akan masuk. Oke. Oke, kita lanjutkan ya. Ibu panjang terus.
sekarang ni yang penting adalah CMV, betul? Dengan normality testing, multivariate normality, remember? Okay, so for multivariate normality, okay, ingat tadi kita kena start nombor 3 dulu. Kita dah start nombor 3 kan, dah settle nombor 3, so we have already finalized our model. We have removed certain, some of the loading that is not good. We have already removed the items, so now our model is finalized. Now we can run or assess the multivariate normality. Right. Okay, let's open here. Okay, for multivariate normality, okay, we are happy with this. Right. So for multivariate normality, go back to open our report again. Okay, look for LVS, latent variable score. Here. Latent variable score. Okay, this score. Click this, the first one. We want to copy to Excel. We want to copy to Excel. These are latent variable score. Right? How many variable? 1, 2, 3, 4, 5, 6 variable. Okay, we want to copy all. Okay, copy to Excel. New Excel, not the old Excel that we use. It has to be new. Okay, go to our Excel and open new Excel. Open new. Empty. And then paste. Okay? Okay? All right. So you can see kat sini, the first column is not variable. This is ID, right? This is respondent ID. The first column. Okay, variable is starting from here, right? Okay, remember, the first column is not. So our variable is column 2, 3, 4, 5, 6, 7. So the column 2 to 7. Okay, that is, okay, you have to remember this. And then you save di tempat yang kita ingat. Okay, save di mana yang saya ingat, maybe desktop. Okay, sekatilah you nak kat mana-mana, tapi make sure you ingat lah. Okay, so I will save it as latent LVS, latent variable score. Okay, di desktop supaya saya ingat. So I saved. Lepas save, tutup. Jangan buka, tutup. And then what we're going to do is, okay, let's go to the multivariate normality again. This one. Okay, this multivariate normality, right? Okay, we have to go to this website. So we want to see multivariate normality. So go to this website. Okay. Go to this website. Okay, let me. Okay, can you see this? Right, this is the app. Okay. Okay, you want to upload that file, that Excel. Right? So choose file. Remember that Excel file is in the desktop. Okay, this one, right? We have to close that. Kalau tak, dia tak boleh nak baca. Dia kena tutup. Okay, so upload. Alright, so data apa? Dia boleh baca SPSS, SAS, CSV and all text. Tapi kita Excel tadi. Okay, kita klik Excel. Klik Excel. So kolom mana? Kolom 2 hingga 7. Kolom 1 adalah ID. Betul? Okay. So 2 hingga 7. Dia boleh buat hingga 7. Ataupun dia boleh buat 2, 4, 5 hingga 9 pun boleh macam tu. Alright. So you baca kat sini. For example, 1, 2 to 5, 7 to 9, 11. Okay. So in our case is 2 to 7. Right. Okay. Calculate lah. Kalau ada missing data, cakaplah missing data apa benda. Tapi kalau tak ada, then okay, calculate. Okay. So calculate. Bismillahirrahmanirrahim dulu. Calculate. Okay, calculate. Okay. Nampak tak dia calculate? Lama. So jangan tunggu. Kalau tunggu sampai besok malam pun dia macam ini. So what you can do is you refresh. Refresh. Okay. So first kita screenshot dululah. Screenshot. Okay, screenshot. Mana screenshot? Screenshot. Copy image. Pergi dekat kita punya Excel tadi. Okay. Kita punya Excel. Okay, done. Okay. Okay, copy. Saya selalu buat macam ni lah. Nanti saya nak pergi makan ke, saya nak pergi toilet ke kan. Saya ada. Nanti saya lupa. So saya terus screenshot. Saya tak suka buat again and again. So this is normality lah. Okay. Yang ini tadi ada discriminability kan. Discriminant. Okay, discriminability. Okay, ini normality ya. Okay. So normality. So you see. Okay. Apa dia punya threshold lah. These are the threshold. Dia tak boleh. Dia perlu kurang daripada 3. Dan perlu kurang daripada 20 untuk multivariate. Univariate 1 dan 7 ya. So you can see univariate here. These are univariate. These are multivariate, right? Okay. So how many variable? 6. Betul? Sample size 150. Betul. Okay. So kita interested in this one. But if you see skewness and kurtosis univariate, dia dah pass sebenarnya. Adalah borderline kan? Tapi sebenarnya dia dah pass, betul tak? You will report that, oh, our normality is great. So we can run multiple regression. No. Itu adalah univariate. Kita run multiple regression, kita run many variable altogether. The relationship between variables. So we have to report the multivariate. In this case, we are using Madias multivariate. Okay, so we look at this. Kita tengok yang ini value ni. Skewness 15, kurtosis 61. P-value very high. Very high pula. Significant. Okay, significant. So 15 dengan 61, dia dah above threshold. So dia, we know that our data is not multivariate normal. Okay, 15 dan berapa tadi? 60 berapa? 61. Yeah. We know that it's not multivariate normal. Okay. So you have to report that. How to report? Go to student facing data project sini. Okay. Yang ini. Sample write up. Okay. Saya sebenarnya dah bagi sample write up lagi. Okay. Sample write up open. Here. Okay. Sebelum structural model, you report this. You report that the result showed that data we have collected was not multivariate normal. Mardias multivariate skewness are, you replace this with the anchor that the values just now. And kurtosis, okay, replace. Thus, following the suggestion of Becker, we reported the path coefficient, the standard error, okay, and p-value for the structural model using bootstrapping. So because our data is not normal, that's why we have to bootstrap. Yeah. Yes. Imagine if we straight away do that without number 3. Ya, kita start number 3 kan, number 3 kan. Tapi reporting wise, you have to start measurement model dulu. Kita nak tengok okay ke tidak semua-semua. Lepas tu sebelum hypothesis testing, sebelum regression, because all this normality is regression assumption. So kita nak flow, we need to report all this stuff, the non-normal or normal, even the common method variance, common method bias around structural model. Okay, especially the multivariate lah, multivariate ya. Okay, let look at the okay, yang ini full clarity testing. Okay, dia guna, kan ada 2 cara tadi, 2 cara untuk check CMV. Okay, 2 cara, right? Cara pertama, marker variable. Cara kedua, for full collinearity testing. So, dalam sampel ni adalah write up about full collinearity testing. Okay? Right? Yang ni kalau you tak collect marker variable. Kalau you collect marker variable, which is a golden standard. Standard yang pertama, gold standard is marker variable. Kalau tak ada, full collinearity technique. But usually if you want to publish in a Q1 journal, they want to look at marker variable. Okay? So marker variable technique. So we are now going to do marker variable technique. Okay? Marker variable. We start with number 3 first, right, just now, but it doesn't mean we report number 3 first. No, mana No. We have to, macam mana nak cakap pun dah terbalik-terbalik dah saya. Okay, we start with number 3 first. Although we report normality and so on, okay? So let's do this. Alright. Mana tadi saya punya SmartPLS? Okay, SmartPLS. Alright. So go back, edit back. Okay, ngam ni. And then now, yang ni dalam-dalam ini adalah semua AVE, correct? Okay, for CMV, we want to look at the R square, the changes of R square. So we don't want this already. We already put and copy and paste in our just now our this. Kita dah buat dah copy and paste cantik-cantik dah kat sini. Right? Semua dalam ni ada AVE semua. Okay? So we don't need that anymore. Now we want to do CMV. So we are interested in R square. So go back here, construct, change to R square. R square. So we would like to see the difference in R square between a model without marker variable and model with marker variable. Okay, and then the changes has to be less than 10%, 10%. Kalau lebih pada 10%, maknanya dia tak boleh percaya your question. Semua orang jawab suka-suka hati, even marker variable pun tinggi, dependent variable pun 5, marker variable pun 5, semua dia jawab 5 daripada A sampai Z. That's why you tengok correlation tinggi dan R square tinggi. Kalau model tersebut bagus, common method bias bukanlah penghalang untuk dapat result yang bagus. Bila dimasukkan marker variable, R square tak sepatutnya tukar banyak. Okay, right. So let's do that. Okay, this is R square without marker variable. Okay, so saya selalu, sebab saya sangat pelupa, saya akan export juga this image. Saya lupa all the time. So saya akan pergi kat sini, saya export this image here. Okay, this is without marker variable, saya tulis without marker, and here is with marker. Okay, and I check the difference. Okay, without marker and with marker. All right. So let's go to the with marker. So what to do with marker? Okay, you can see this is the only endogenous variable in this model. Okay, ada model yang ada many endogenous variable, especially if a model with mediator. That means dia ada banyak R square. Okay, dalam model kita sekarang ni kita ada hanya satu R square. Okay, jadi kita compare satu R square. Okay, so what we do here is we drag in the marker variable. Drag in, drag, release, enter. So this is our marker variable. Okay, this is our marker variable. Okay, so we are in the select mode, right? We want to connect. So click connect and connect, release. So you can see. Okay, so supaya kita tidak lupa, kalau kita dah sudah tua, kita lupa. Jadi kita nak export as image again. Okay, export as image again. Kita pergi kat sini and tengok. Okay, dan kita boleh pergi masak ke, mandi ke, mayang ke, kan. Dan datang balik. Oh yeah, there's marker variable. Okay, 0.329 and 0.335. Is it more than 10%? The R square, the changes. Saya tak tahu, saya very bad in math. Berapa persen changes? Less than 10% lah. Kalau more than 10%, that means 0.3 jadi 0.4 lah kan? Betul tak? Okay. So how to report? Okay, how to report this? Okay, is let me see.
No, 6. Less than. Yeah.
Okay, report that. Okay, report that. So how to report is you can see my paper lah yang electronic ni, CMV ni. Okay, nanti saya bagi paper ni lah juga kan. Okay ni. Jadi report. R square without marker variable, R square with marker variable, the different. That's how to report. Okay, how to explain. Right, untuk the to report common method variance, okay, I will give you this paper and you just can rephrase from what I wrote. Okay, masuk ChatGPT ke Claude ke, and then rephrase. Okay, and then make sure that you have all these things. Miller and simmering is attitude towards color blue. All right, attitude toward color blue means, let me see kalau ada. Sebentar ya, azan. Kita tunggu lepas azan. this paper, these two papers that I've been showing you, right? I've already what we call that? Share it in the Dropbox. The link. You have to click the link again and download the paper. Okay, this one. Okay, this the link that Dr. Yusuf, Pak Dr. Yusuf, yang share with you, yang dah share. So you click that link again and you can get these two papers. I've just shared it. I just drag it in. Okay, right. So these two paper. Okay, so when you open that paper, you just can what we call that, search CMB. Okay, search CMB, and then you boleh tengok, boleh lihat macam mana saya report CMB, and then the table, how to report CMB, and then the table also. Okay, both cara report is a bit different. Untuk paper yang lagi satu ni, cara report begini. Okay, and then the endogenous construct ada dua. Okay, right? So you have to point the marker variable to all endogenous construct. So kat sini endogenous construct ada dua, because attitude also endogenous. Mana tadi attitude? Okay, kat sini ya. You can see ya, attitude dua, right? Attitude. Okay. So R square sini, R square sini. Yes. So attitude is the mediator. Kat sini, di sinilah. Okay. Okay. Alright. Okay, so marker variable finish. Multivariate normality also okay. No, the last one. Hypothesis testing. Okay, so we take out the marker variable. We've already done marker variable, delete. Marker variable is not part of our model. Okay, there's no hypothesis about marker variable. We just want to check whether CMV or CMB is an issue or not, right? Okay, there is a difference between CMB and CMV, yeah? CMV is R square. R square is variance explained. Okay. CMB is biasness, this one. This one, okay? All right. For CMB, okay, let me show you CMB again, CMB. Okay, let's drag again, marker variable. Okay, just quickly, I show you. All right, this is CMV. Okay, CMB is you have to bootstrap. You have to bootstrap 1000. Okay, 3. Okay, percentile bootstrap, percentile, and one tail, because our hypothesis is directional. All right, and then we start calculation. Okay, so for mana calculationnya? Belum keluar. Okay, so calculation the default is T value. P value. Nampak tak ni? Structural model P value, right? Yang ni semua jadi P value. P value. Dah tak, there's no more loading, because we have already bootstrap now. This is bootstrap, Okay, bootstrap. And kalau you nak tengok, jangan takut, result tadi masih ada, dia tak hilang. You go to other results here. Yeah. Go to other result, go to PLS-SEM, and you can get the result. So we are now bootstrapping. Okay. So bootstrapping, dia punya default mode is, once you run bootstrapping, dia terus jadi ni. Okay, dia terus jadi P value. So we don't want P value, we want P value and beta. Okay. So P value and beta, you go to structural model, click, and then change. Change to path coefficient and P values. You can also change to path coefficient and T value. Okay, path coefficient is beta, standardized beta. Okay, another name is path coefficient. Okay, another name is path coefficient. So let's click here. Okay, so you can see that, you know, this is the standardized beta or path coefficient. Inside the bracket is the P value. As you can see here, this one is not. It's not significant. Okay, but now we are not interested in structural equation modeling yet. I'm interested to explain to you about CMB bias. So CMV is the biasness of. Okay, tengok, tak boleh gerak because I'm in connect mode. So go to select. Because I nak gerakkan ni. Okay. So I'm interested in the biasness. Okay, bias is when you say CMB, that means after you add marker variable, there's a changes in this. That means sebelumnya signifikan, selepas di masukkan marker variable jadi tidak signifikan. Ataupun sebelumnya tidak signifikan, selepas masuk jadi signifikan. Yang tu bias. Right? Bias. Okay, CMB and CMV. V is variance. B is bias. Okay, so that is how to report lah if you want to report. Tapi mostly people just report CMV, but at least you know what is CMV. Okay. Okay, saya nak remove marker variable ya. Remove delete. Okay, automatic right?
Automatic.
Okay, so we have already done the bootstrapping just now. So this one is step seterusnya, right? Step seterusnya adalah ini. No, bukan. Step seterusnya adalah ini ya. Okay, structural model assessment yang kita perlu report standard beta, standard error, t-value, p-value dan upper limit and lower limit as well as the effect size. Okay, let's look at my paper. Okay, my paper pun buat benda yang sama. It's not a rocket science. Dia sangat-sangat senang. Pass coefficient, standard deviation meaning standard error, t-values, p-value, lower limit and upper limit. Okay, yang ni penting dengan F square. Okay, so signifikan atau tidak ini kita punya decision. Kita tulis kat sini, tambah satu, whether significant or not. Yes, significant. Okay, signifikan, apa dia signifikan? Apakah signifikan? Signifikan adalah bila the p-value adalah kurang atau sama dengan 0.05. So it has to be lower. The p-value lagi kecil, lagi bagus. Mesti tidak lebih daripada 0.05 p-value. Ya, so yang ini tidak lebih, signifikan. Yang ini tidak signifikan sebab lebih daripada 0.05. Dia 0.07. Tak boleh. Okey, itu satu ya. Okey, yang ini semua 0.000 lah sebenarnya. Yang P macam ni, right? Sebenarnya result dia adalah 0.0000. But in statistic, there's no such thing as 0.0000. No such thing. So kita buat P bawah daripada 0.001. Okay, right? Tapi you akan nampak dalam result dalam your SmartPLS as 0.000. Okay, ada soalan tak? Do you have question? Okay, let me repeat. You need to have path coefficient, which is your beta, standard beta. You need to have standard error atau standard deviation. You need to have t-values, p-values. Yang ini adalah the central theorem, apa yang cakap tadi? Central theorem. Yeah. Okay. Lower limit and upper limit. Okay. So you can see here, saya kata tadi kalau dia significant dan you kena confirm juga dengan lower limit, upper limit. Lower limit, upper limit tak boleh ada 1 atau 0 in between. Ada plug in. Saya begini. Sekejap ya. Okay, mana tadi ya? Okay, kalau evidence yang kita perlu bukan saja kita tunjuk beta dan p-value, kita kena tunjuk the whole thing. So you can see here, there's one that is not supported or not significant. Significant no. So you can see that bila significant no, the lower limit, upper limit, mesti ada zero in between. Negatif dan positif, right? Kalau you pergi sampai ke positif, mesti ada zero. Betul tak? Ya, kalau ada zero, that means it's not significant, which is commensurate dengan p-values-nya dan juga t-values-nya. So ada 3 benda nak tahu something significant. Tak cukup saja dengan t-value atau tak cukup saja dengan p-value sekarang ini kalau you nak publish in good journal. You have to have t-values, you have to p-values, you have to have upper limit and lower limit. Semua kena sama, make sure. Kalau t-values bawah daripada 1.645, that means p-value has to be, sorry, kalau t-value-nya adalah, ya bawah kan? Ya, bawah daripada 1.645, p-value-nya mesti above 0.05 dan LL dan upper limit-nya, lower limit dan upper limit-nya mesti ada, boleh kita letak 0 atau 1 in between. Okay. Kalau the other tengok, semua tak ada. Semua positif, 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 positif. Yang ini saja yang negatif, positif. And yang ini nampak negatif, negatif. Negatif, negatif, maknanya dia pass coefficient negatif. Kalau yang positif, pass coefficient-nya, mesti yang ini dua-dua positif. Kalau dia punya pass coefficient negatif, that means yang ini pun negatif. Sama, moderation. Kalau you ada moderation, here is direct effect kan? Yang ini moderation effect, betul? So even moderation effect, you have to have all this. Bukan saja direct effect, ya? Even moderation effect. Okay? You also have to hold this. Alright? So let me see apa lagi table di sini. So bila, okay. So this is the thing, ya? This is structural equation modeling, right? Table. So we want to have this. Nampak tak yang ni tak ada lagi dah rambut-rambut. Apa dia punya items, right? Sebab kita tak perlu dah. Kita dah sampai tahap structural equation modeling. Jadi kita tak perlu dah ada benda-benda ni semua. Kita boleh hide. Okay? So you can see here, this one. Let me see. Okay, here, loadings and average variance extracted. I don't hide. I didn't hide this. Because the purpose of this figure is to do measurement model assessment. That is the purpose. So you can see inside here are AVE, not R squared. Okay, when I reach structural equation modeling, I already hide and I make sure inside here are R squared because that's the purpose of this figure. So you need to know, whenever you do something, you need to know why. You tak boleh ikut saja. You kena tahu kenapa saya buat ni, kenapa I kena buat ini, kenapa. You have to make sense. You have to make yourself understand. Okay, so let's do this. Okay, this table. Okay, sikit lagi ya guys. Sabar ya, sabar. Alright. So here we don't want this anymore. We don't want this because these are not loading anymore because we already bootstrap. So we want to hide. So how to hide is select all. Okay, select all and you just put your cursor anywhere lah. Okay, and right click. Hide indicators. Hide. Okay. So inilah kita nak tunjuknya. Okay. Arrange lah cantik-cantik kan. Kalau nak arrange lebih. Tapi kita tak ada masa dah 3:30 kan. Kita tak nak arrange. Kita just nak copy, export as image. Okay. Alright. Maybe pergi dekat kita punya. Apa dia? Okay. Yang ini CMB ya. CMB. Markable. Okay. So yang ini SEM. Okay. You can put in your paper as well. Dalam appendix ke mana-mana ke. Okay. Boleh letak. Okay. Last one guys. So here is how to report. How to report. How to report like this. Mana tadi? Macam ni macam ni saya nak tunjuk mana nak dapat value tu dalam SmartPLS Okay, bear with me a little bit more. So let's go to PLS. Alright, kita dah bootstrap kan? Okay, semua orang tahu macam mana nak bootstrap, right? Pergi calculate, bootstrap. Okay, bootstrap. And then you get, okay, let me bootstrap again, just to make sure that everybody understand. Make sure your bootstrap is 10,000. The default is 5,000. You have to change. 10,000, 10,000. 10,000. Okay, most important faster. Okay, you can do this as well, complete, but complete dia slower. Slower means dia akan bootstrap every single thing in the whole wide world. So no need. Keperluan kita adalah yang ini, biar laju sikit. Okay, bootstrap ada 3. Kita yang ini, kita choose percentile bootstrap. Kita choose bias corrected kalau terlalu ketosis dia teruk. Ketosis dia, normality dia memang teruk, then only we choose this. Okay, our default is percentile. Okay, percentile, and then one tail. Remember one tail because our hypothesis is directional. Yes, and then significant level. Okay, fix it, bukan random seed. Fix means bootstrapping tu dia random. Dia akan ambil dan replace. Dia random. So kalau you letak random seed, every time you bootstrap, dia tukar dia punya values. A little bit only. A little bit. A little bit, tak banyak lah. Dia tukar. But we want to make sure that the values are consistent. Nanti dalam table value lain, dalam figure value lain. No, cannot. Dia tak boleh, dia kena sama. Okay? Dalam table sama, dalam write-up sama, dalam figure sama. So better letak fix it. Okay, then start. Start calculation. Okay, you will have this again, right? So how to report? Go to open full report. Open full report. So go to path coefficient. Okay, path coefficient, and then copy to Excel. You can copy to R also. Okay, copy to Excel. Okay. Kita main Excel je. Ni. Okay. Okay. Sheet 6. Okay, copy to Excel. And paste. Right. So we have this. Okay, you can see that we have original sample. Okay, this is our beta. Literally, everything is original sample in the result. If you look at F square, you will see original sample also. Okay, so you have to know what value is this, right? So this value is actually path coefficient or standardized beta. So change to standardized beta quickly. And then sample mean. Okay, we don't want sample mean. This is sample mean of bootstrapping. So we want to remove. Bukan mean. Dia punya mean. Ni bootstrapping punya mean. So we want to remove. Okay. So standard deviation. Okay. Standard deviation, you can put standard deviation atau standard error. Okay. T statistic is the T value. P value. This is P value. Yeah. Now what do we have to look for is the lower limit and upper limit. Betul? Okay. Go back. Go back. Here still. Final result. Path coefficient. Here. Here. Yes. Upper limit and lower limit. So we want this. Disebabkan kita, saya tak tahu sekarang ni boleh ke? Rasanya tak boleh kita copy 2 row saja. Okay, let me try lah. Let me try.
Jam berapa sebab? Mulai.
Okay, let me try. Okay, copy
Jam.
SEM. Kita copy 2
Jam
row
berapa
saja.
jarak tu?
Tak boleh kan? Dia pergi keluar semua benda juga. Okay.
Acara dengan Pak Bambang.
Alright, so we want this.
7.30.
So all other things
Mungkin
we
dah
don't tengok sama kan? Standard beta pun sama.
Memang
Sama.
lapik 7.30 tu.
Okay, so we don't want this one because we already have.
Ini Pak Bambang
We
lah
don't want
setelah
this.
di Siko berarti ya.
Okay, we don't want this. We want only lower limit and upper limit. Okay, let's remove.
Okay.
Delete. Okay,
Ya,
so this
langsung
is what
lah.
we want.
Kalau jam-jam 9 kan anak-anak buka.
Okay,
Anak-anak
so make
tak
sure
ada
everything
kegiatan
is
kan?
in a
harus
3
belajar
decimal
aja
point.
dulu kan gitu. Kalau jam 7.30
Right?
ya langsung.
3 decimal point. And then P value 000 ni. You can see P value ni pun ada color coding. Merah tak significant. Okay. Hijau significant. Significant. So you can see hijau ni kita kena tukar kepada P below. Okay, sorry macam ni 0.001 macam tu. Okay, this is the correct way of reporting. Right? Yang 000 ni. Okay. So let me see in the middle. Okay. Okay. Apa lagi? Okay, daripada sini tak significant and you see, okay, bila tak significant, let me make a big bit. Okay. Bila tak significant, okay, memang betul. Okay, satu negatif, satu positif, betul? The upper limit and lower limit, ni upper limit, ni lower limit, ni PCI, PCI, lower limit. Ni PCI, upper limit, Okay. So, you can see that kalau this tak significant, dia akan ada 0 atau 1 in between. Kan? So, ngam, semua sama, coherent. Okay. So, this is evidence that everything is good. Okay. Satu negatif, complexity negatif. Cerdas beta. Tapi tak significant. Negatif tapi tak significant. Okay. So let's look at our hypothesis. Where is our hypothesis again? Okay. This is relative advantage has a positive effect on cloud computing adoption. Okay, betul tak? Relative advantage has a positive, betul? Okay, positive, significant, betul? Okay, this is significant. Okay, so you tengok positive and significant, jadi kita boleh support lah. Supported lah dia punya hypothesis, right? Support. Okay, this is your decision. Support tak support. Okay, right. So, okay, that relative advantage. Relative advantage is which this is H1. Okay. Relative advantage adalah H1. Okay. Kita sini H1. Okay. And then H2 adalah complexity has a negative effect. Okay. H2 complexity H2. Tapi memang betul negatif. Tapi dia tak significant. Okay. Dia tak significant. Jadi not supported. Not supported. Right? So H3 triability has positive. Okay. H3 adalah triability. Triability positive, yes, tapi tak supported. Because p-value dia adalah lebih daripada 0.05 dan t-value dia adalah kurang daripada 1.6. No, 96 is two tail. 96 is two tail. 1.645.
One tail.
1.645, ya? 1.645. 1.645. Kat sini, di sini ya. Ada kan? Okay. Alright. This one. So this one not supported also. Okay. H4 visibility has positive effect. Okay. Ini H4. Alright. Visibility has positive effect. Okay, significant support. Alright. The last one, H5, is compatibility has positive effect. Okay, support juga kan? Okay, support. Ni H5. Okay. And then ni pun support. Okay. So the next one will be what? F square effect size. Okay, F square. Okay, kat mana dapat effect size? Adalah di sini je. Yang mana? Okay, F square. Tak boleh, nampak tak? Kita kat bootstrapping kan? Kita masih di bootstrapping output. Kalau you klik kat sini, tak ada F square. Okay, kat mana nak cari F square? Kita kena balik kepada path algorithm. Sini. Kat sini. Oh, dua bootstrapping ya. Okay. Kalau tak ada path, tak apa. Jangan takut. Pergi calculate PLS SEM again. Calculate again. Okay, calculate again. You are in PLS SEM mode. So go to open full report, look for F square under quality criteria. F square. So these are the F square. Okay, these are the F square of compatibility kepada cloud computing, complexity kepada cloud computing and so on. Alright, so we copy to Excel, copy to clipboard, and kat sini lah ya. Oh. Okay, buat. Okay, betul ke? CCA compatibility to cloud computing H1. Right, nanti kita silap. Compatibility Compatibility, complexity, relative advantage, stability, visibility. Compatibility, complexity, relative advantage, stability, visibility. Okay, betul. Betul arrangement dia. Okay, then only we can copy. Kalau tak betul, takut lain kan? Okay, kita copy and letak di bawah ini. Macam tu. Okay, and then let's remove this. Delete. Okay. Okay, again, this one also 3 decimal point. Okay, so yang ini effect size. Okay, we have to make the decision. Okay, two decision we have to make here. Not decision like interpretation. All right. One is this decision whether it is support or not support, significant or not significant. Support or not support, whether it follows the relationship that you have already proposed to test in your hypothesis testing. Okay, right. Second is effect size. Also another decision. Small, medium, large. Okay, kat mana? Yang ini adalah direct effect. So kita tengok cohort 0.02, 0.02. Mana? Okay, here. Jadi kita ada discuss tadi. Effect size. Sini pun ada. Effect size. Okay, actually redundant. Sini ada. Dan sini pun saya tulis lagi sekali. Okay, it's the same thing. So 0.02, small. 0.15, medium. 0.35, large. So this is medium, right? Right or not? Because it is above 0.02, betul? Yeah, so medium. This is 0.02 ke 0.2? 0.02. Ini medium. Yang ini adalah no, salah ni. Ni small Small. Dia macam ni tau. 0.02 to 0.15. That range. Bukan bawah daripada 0.0. So this is still small Small. This is medium. Because dia dah sampai 0.15. Okay? Dia dah sampai 0.15. We can assume, we can translate. Yang ini none. No effect. Yang ini medium juga. Yeah? Okay. So that's how we do it. Okay. And then now semua dah settle. So sini adalah hypothesis. Ini adalah path or relationship or something. We can say relationship as well. Okay. Right. So kita boleh actually sort. Now we can see H5, H2, H1, H3, H4. Right. So kita boleh sort je. Sort A to Z. Sometimes macam ni lah. H5 ni dia tertinggal Sekejap ya. Tapi kita buat macam something like this Insert and then sort. Okay. Like that. So that is alphabetical order. Correctly following sebab sometimes bukan. Okay, again. Okay. Okay. So sekarang ni settle. So yang ini adalah kita punya SEM SEM table. SEM table. Yang ni SEM gambar. Yang ni SEM table. Right? Okay. Maybe yang ini kita letak bawah macam ni. Oh, dah. Okay. Okay, saya rasa sampai sini saja lagi ya. Alright, and I've already given also some of the data. You can play around with the data. There are a few other data, right? So kita berpeluang untuk you know, guna satu data saja cloud. Okay. Okay, I hope the bangkit atau workshop hari ini successful. I mean, you have learned something and grow and beneficial to certain extent. Okay, so if you want to extra, then we can do maybe, you know, when I go back to Malaysia, you know, and we can do online. Apa boleh juga, you just go. Okay,
Okay.
online quite good also because can record, right?
Ya, can record. Oke. Terima kasih luar biasa. Kita berikan aplaus dulu buat Dr. Ezlika. Betul. Ya, sepertinya karena waktunya memang sudah tidak memungkinkan. Tapi ya kami sangat appreciate dengan workshop hari ini. Kalau untuk mengolah itu mungkin semua bisa mengolah data dengan tools. Tapi yang tadi yang terpenting, yang pelajaran yang mungkin bisa kami ambil hari ini adalah how to interpret and how to write. How to present it. Ya, itu sangat penting dan tidak bisa dipelajari sembarangan gitu ya. Memang alhamdulillah Dr. Ezlika bisa memberikan sini ya, dan semoga berkah juga ilmunya Dr. Ezlika, dan semoga kami bisa mempraktikannya dengan menulis paper Q1 ya. Amin.
And you know, terima kasih dan mohon maaflah jika ada any glitch, okay, any glitch and any ketidaksempurnaan, right? And semuanya yang baik-baik semua datang daripada Allah Subhanahu Wa Taala, yang tak baik-baik itu daripada saya ataupun syaitan yang direjam. Okay.
Sepertinya harus lanjut karena hari Jumat mau lanjut ya. Oke, kita diskusi dulu ya. FGC.
Okay.
Ya, moderating and mediation itu sekarang ya model-model penelitian di mahasiswa kita juga sekarang arahnya ke sana gitu,
Betul.
dan itu mungkin kita juga perlu dibekali, dan mudah-mudahan juga mahasiswa tadi sampai 100 lebih mungkin ya, dan itu juga mungkin membutuhkan itu gitu. Ya, kita bikin poster part 2. Oke. Ya. Langsung mediation moderation langsung ya ini ya intermediate ya advance dan intermediate class. Oke. Sekali lagi terima kasih jazakillah khair untuk Dr. Ezlika. Mudah-mudahan tidak kapok untuk terus kapok Eh, nah not regret. Tidak bosan. Oh, itu ada nggak sih? Mama sudah bosan. Ya. Oke. Ya, karena waktunya ya, sekali lagi waktunya tidak memungkinkan. Ya, semoga kita bisa ketemu lagi di hari Jumat, dan mungkin di kesempatan lainnya kita membuat kelas-kelas online. Sekali lagi terima kasih. Dari saya sebagai moderator, saya tutup dengan ucapan hamdalah. Alhamdulillahirrahmanirrahim. Wassalamualaikum warahmatullahi wabarakatuh. Balikan lagi ke Rin ya.
Baik, terima kasih Pak Yusuf, terima kasih Prof. Ezlika. Tidak terasa seluruh rangkaian kegiatan workshop pada hari ini telah kita lalui bersama. Semoga setiap sesi yang telah disampaikan memberikan wawasan baru serta memperkaya pengetahuan dan pengalaman kita semua. Dan kindly reminder, jika Bapak Ibu hadirin sekalian berminat mengikuti sesi 2, nanti akan dilaksanakan lagi hari Jumat dengan link Zoom yang sama. On behalf of the organizing committee, I would like to express our sincere appreciation to our distinguished speaker, Associate Professor Dr. Ezlika Binti Ghazali, our moderator, Dr. Yusuf Murtadlo Hidayat, and the head of the Business Education Study Program, and everyone who has contributed to the success of today's event. May today's workshop inspire future research, encourage stronger academic partnerships, and open new opportunities for collaboration between Universitas Pendidikan Indonesia and the University of Malaya. Semoga kerjasama yang telah terjalin pada hari ini menjadi langkah awal bagi kolaborasi yang lebih luas di bidang pendidikan, penelitian, maupun pengabdian kepada masyarakat di masa yang akan datang. So, yeah, I have a little pantun. Roses are red, violets are blue. Knowledge are shown when it's shared with you. Wassalamualaikum warahmatullahi wabarakatuh. Thank you very much for your participation.